So I guess that it's here on products, but I'm not entirely sure of it. Here it says educational access. Yeah, there it says access. And let's see here if we go, is it going down or what happens if we go down here?
Get products.
There, I think so, but I'm not entirely sure. And then you are already signed in. So I guess that, yeah, exactly. And then download Fusion 360. Perfect. Yeah, okay. Perhaps
I'm trying to click it, but
if we go up again, I see that. Let's see here. If you press this one, I think it's a little counterintuitive because you are already logged in. Because now perhaps it worked. We'll see. Does it work? Yeah.
Yeah. Now we have to get started.
Perfect. Yeah, I think it's a little counterintuitive that. And then university, add to profile, and it should be name of educational constitution. Is it? Yeah, try what is it called now? Royal Institute or something like that. Aha, okay, sorry, it's not in Switzerland.
Oh yeah, that's Sweden. I'm from Switzerland. That's how it comes.
Yeah, I assume so now. But Sweden. If you choose Sweden, there it should be. Yeah. Oh, sorry. It was, yeah, there. KTH Royal Institute. Perfect. And then confirm. Please select a country. But re-enter the institution name. Okay.
But this is.
I don't know why it says so here from Sweden.
Do you think he will ask for, because let's go, if I put my home university in just to test.
Yeah, of course. It's perhaps it's not only KTH students which has accents. So maybe
it's what? I thought maybe my profile is set to Switzerland, so it doesn't allow the change. But
yeah, but now it says please select a country for Switzerland as well. So
yeah, so it's not this the problem.
Perhaps it's an age-old like troubleshooting thing. But I am not sure if are you in a cookie-less mode, or are you in like private mode or incognito mode or something like that? Perhaps it's like it wants a cookie from Sweden or it wants a cookie from.
I don't think I have no VPN.
No,
on.
okay.
I have no. Should be the normal. It could stop the ad blocker, but there's no ad on.
Yeah, I don't think they have. It would be excessive to have ads on a commercial. But I would like try to refresh the page. I don't know why this happens. Featured and page and filters.
Sweden.
Yeah, actually, it's now it was another one. So let's try this.
Now it works. Okay.
Okay, so refresh the page if it doesn't.
Good old refreshing.
All right. To get this document, in a new tab, you go to kth.se.
Yeah.
And then up here where it says click to retry, you can, if it's logged in exactly. And then I'm not entirely sure. I think if you press your name here.
To get the document, or?
It should be perhaps if you press program here. No, it says if you press here, it says contact details in LawDoc, so that we go to the LawDoc webpage. And then if you log in with your KTH credentials. Yeah, let's see here. If we look at the menu over here, and then go to transcripts and certificates, and then it was now in the end it was obvious. If you create there, you can create, and then there should be a certificate of registration.
Yeah.
Because that means that you are registered. And for this matter, take already, or yeah, I would say all registrations arranged by a program and English. If you go back to the Autodesk tab, did it say that you have to include anything of this to the right there? It must include your legal name and the date with the current school term.
So this should be all in it.
Yes, actually, the registration for a certain period might be enough, but we can like upload the master document. So
yeah, that's
all right. And there we have a certificate of registration. And let's see here, your name and the period it says here. Yes, and the print date, and what they required something more, the date of the registration, I guess. Very good. I guess that this is the document that they require. So if you just download this.
Should I change the name of it, or
perhaps with your full name? I would do that.
Registration, or no, the
it says here the preferred documents include a transcript, a school issued confirmation letter, and a copy of your student ID.
Yeah, I think
so. I think that's good. Yeah, and do you interpret it as well that preferred documents include then that all the three of these are like equally valid? So that the document that we're uploading now it's a sort of transcript or school issued confirmation letter, and it's good.
Yeah.
I
mean,
all right, then we submit.
I think if they're not happy, they will contact me.
And now it says, of course, that the verification process can take up to 48 hours to complete. But you know, if we encounter such a thing as we do now, then we just like slightly change our modus operandi, because like we can take the full. Well, okay. Wow. I was so much expecting that this would take like 2 full days, and but it was like I don't know, it was half a minute or so.
That's great.
They were typing or watching closely there, or very fast. So then get products and access. Perfect. That's good also for the. Yeah, and now it has already downloaded the client, but it will download more while you install. So if you open this, and do you have enough storage room on
yes,
hard drive? And yeah,
a storage room is always lacking, but I will put it on the. I have all the programs here, so
yeah, and this might take a while.
Okay.
Yeah, here we see some 2.5D milling. This is
Maybe a quick question, or just I'm curious to see, how did you come to be our CNC expert?
And then I don't know, like I don't know 10% of what Gabriel knows.
Yeah.
But one thing that is really good for me is that I don't want to work more than like 50% if that ever happens. But now, as of now, I'm a student operator, and as such, I can work 8 hours a week, which is. It's not something to like sustain. It's not sustenance or what you call it, but it's really fun because I love the art of CNC making, and I find this. I would perhaps not call this a tutorial, but like I really like the aspect of teaching as well. So
yeah,
it's good. And now to sign in here, you sign in with your email address, and I think it was your Gmail email address. Yeah. So,
what's the Gmail? I already forgot because I usually.
I think it was because I did not know beforehand exactly what Autodesk required, and I thought naively that perhaps they require a KTH address to make it work. But it's super fast recognized that you were reliable.
He's actually
all right, and for this you can create a team. Fusion 360 has actually excellent. You can work simultaneously on the same project, several people, but like as an architecture student, that it might not happen that often that I know that it's very common in the offices. But for students, most like you create your own team and you have your projects and they are synchronized to the Autodesk cloud, and from whatever computer you log in with Fusion 360, it gets downloaded from the cloud. So it's but it got so you can create a team and enter a name, like any name.
like let's make Blue Fire. Let's make it a bit. I have no clue.
Yeah. And this one, I will just read it in the small fine print here. All right. So this is if you are cooperating with someone who you want to find you, like search for your Blue Fire team, then you can allow discovery, but you can, for now, do not allow. I will guess that if the need ever rises, then you can change the setting.
Yeah. Okay. So great.
It's really good because now everything is set here for the Fusion 360 part. It's just that we might have like gone forward with this step. I think it's good that we have actually gone through this step, because now the verification process took like half a minute, but if it would have taken an hour, then we could have gone to Rhino and continued to work there. Because Fusion 360, like there are several different so-called CAM softwares, computer-aided manufacturing, or I think it's called that. Yeah.
Okay.
And Fusion 360 is one of many. And the perk of Fusion 360 is that it's very pedagogical in its user interface and very pedagogical in its whole user experience. It's very, what do you call it? What you other CAM softwares, they might be like a steeper learning curve.
And then, I know.
Yeah, and then you might, in the end, after you have mastered the software, you might be able to do more things like customized. You might customize your own toolpath in a like premeditated way. I want to do precisely this, and then commute that. Fusion 360 has both the perk and the con of being more like you input something, you let the software analyze it, and then the toolpath, depending on the parameters you set, is your outcome. And it's like more of a black box, not you as a user taking
control. You're like losing a bit of control.
You're losing a little bit of control. But since the results, for my experience, have been so good, and since the user experience is so good, in Mastercam, which I am not a master in, I am a novice in Mastercam, but I am always like intimidated by the fact that if I do something wrong here, then this like 100,000 euro machine might actually like interpret what I thought I was doing, but actually not doing, in a way which might turn to disastrous results. Fusion 360 is much more streamlined in such a way that you can you like see the simulation of what you are doing, and you can be fairly certain that there won't be a conflict or a collision, but you always simulate and make sure that as well. But I prefer myself personally Fusion 360, and I encourage, if you learn one software in the beginning, I would suggest it would be Fusion 360. But there are alternatives, and like if you want to like just test out Mastercam without necessarily producing a toolpath, you can open it on it's installed on the computer outside of the CNC room. But it's like a user interface from the 90s, and you're not really knowing where to look for anything you want to do.
Okay.
But let's begin now, and like I said, like you have to input a model. It works with a NURBS model, like you output from Rhino. But given that, we should return to Rhino and actually produce such a model. And we have a model here. but we should try to make like a really small portion, not necessarily like the one we are actually milling tomorrow.
Okay.
Just to make sure that it works and that the workflow is set. So I don't know. Did you make like a duplicate copy of it?
Yes,
now? So that's everything.
I just saved it. Yes.
Yeah, perfect.
Now
because then perhaps to make it, I'm really interested in these like the roofs of those, how that will turn out. So I suggest that we take a portion including these. But then let's see if there's anything, if there's any other geometry which, because the landscape itself, it's like undulating up and down, but that should not be. The landscape models are like unproblematic in their essence, because they are in most cases constructed from a height field map. I guess that this is as well.
Yeah, it's their level curves. Poof. So this is like the patch, I think.
Yeah, and perhaps the these curves, do they come from an image or do they come from
a file? Like I took it from like it's a file. I think it was like the type plan or.
Yeah. Okay. And most of these. Like in a urban scale or like in a large scale, most of these height models, it's called DEM, digital elevation models. They are created by aeroplanes flying over the area and sending these. Now, I don't know exactly the
measuring the distance, like to create it.
And given that. Like method, the output is an image with like white, or actually it is a series of numbers, but they are interpreted as an image with white being the highest point and with black being the lowest point, and all the range from black to white between there. So that's why these elevation models are like unproblematic to fabricate with the 3-axis CNC mill, because they are, if my assumptions are correct, they are created in a way that is like similar to how the CNC mill actually works. It works like from the highest layer to the lowest layer, sequentially each layer per layer. So even though this has been like you have constructed a patch from the level curves, it's still like the source material should be unproblematic. There should be no overhangs. Like if there's a cliff and then there's a cave, the aeroplane would not have like reached with the laser inside. So there should not be any overhangs. So this was like a long tirade on how the landscape itself should not be problematic at all. But these pitched roofs, I wonder what tolerance levels we can achieve to like actually replicate that. Is this model in scale? Is it in 1:1, or is it in scale you want to fabricate?
It's 1:1.
It's 1:1, because that's good.
And yeah, I think interesting could be like these gabled roofs, maybe the church we have here.
One as well. Yeah, that would be good.
Personally, I'm really interested also in the terrain, but as you said, like
and we will include the terrain, but I do not think that like any specific part of the terrain is more worthwhile to test than any other. But I think that those buildings might be the most complex to fabricate.
Well, one question I had, I made sure it's no problem, but while in a sense how I dealt with it, it's like I mean, I had like above, I had the grid, and I was modeling the building, and once they were ready, I was putting them onto their place.
Yeah.
Then I was checking that they have everything. I think it was like checking
that's perfect. That's really good of you.
But then I was wondering what would happen. I mean, if in case, let's say that this building would be a tiny bit above, and we create this small space.
Yeah. The thing is that we will make a Boolean union of all these, and it will be a NURBS model, and as long as it's a valid closed polysurface, whether or not I'm pointing at the screen here, but whether or not it will have this overhang or not, this overhang will not be able to be fabricated. But it might. We will always check this with the simulation, of course. But as I presume Fusion 360 to work here, as long as this is a valid closed polysurface and we input it to Fusion 360, it will analyze the topology of the whole model to interpret how to mill it, how to fabricate it. And this one, this overhang, I would simply guess that it will not be a problem, but it will certainly not be milled.
Yeah. Okay.
But then again, by leaving this gap, you will make the polysurface model more complex, because if it would have been like properly inserted, then the whole bottom will be I would like to say evaporate, but it will be merged and obliterated. But if we make a Boolean union of this, as you know, then the underside of this will still be kept. So that will make it for a more complex model at the expense of computation time, which is not something we want. So it's really good that you have made the effort to to let the volumes sink in a little. But if there is somewhere where you have not done this, and if the Boolean union process still allows for it, then there's no problem.
Okay.
Yeah.
And the other part, but I think that's probably also solved, was I think it was part of some buildings here, but I made sure that like this, or
and this is the same, because we will choose a so-called the parameter is called tolerance in Fusion. And I usually set this to 0.5 millimeters, half a millimeter, because like that's the amount that I can perceive. See. We have, of course, in school, and I don't think perhaps there is. We have, of course, no tool that would be able to cut such a small and narrow gap. And thus, I would presume that Fusion 360 simply will neglect this gap. And but this is really good that you showed, because I think that is a valid reason enough to include this in our box that we try. We have now triangulated like an area of points of interest.
We can. I mean, talking about, I think it was I was just afraid that it gives like at some point an error. Like that, and then
it might throw an error in Rhino, because Rhino is working with tolerances as well. And I don't know if you hear Manfred in the background or not. But sorry.
That's fine.
When we do the Boolean union, perhaps like depending on your experiences with Boolean operations, they can be really frustrating because they fail for some reason, and then you move like 1 millimeter to the side and then it works. And that's usually because the tolerance, the maximum, or is it minimum? But you know what the tolerance is. Will the operation include these two elements as one, or will they interpret it as two? And if it's like straight on the line or within the tolerance, then it will have problems designing that.
So what I can do, since we said that we have like now these different points of interest, what I can also do is, since now it's about testing, I can also just take this saying and copy it over here. We have this. So we have this part here.
Yeah, that's really good. That's as long as the topography of the landscape allows for it to, so as not to produce too many. Like, is the building that you moved, is it properly?
Now I have to double check it.
Yeah.
But but actually there's another. Is it this one?
Yeah, I think it's that one. It was
really this is, and the height doesn't really matter. I can just leave it like this.
Yeah. All right, because then you can hide the level curves layer, and then if you enter top view, and yeah, and try to locate, yeah, there, and then we can make well, we can either make a box or a rectangle. Since we are in a 2D viewport, we can make a rectangle. I think something like that.
Yeah. Like this, or
yeah, perfect. And then we can change back into perspective mode or a 3D viewport, and then we can make that a planar surface, so planar SRF, or I don't know exactly where you
this is it. This one? No, this is,
yeah, I think that's the one.
It's weird. Certain commands or not. Yeah.
Yeah, and then we can extrude surface. So EXTR or
it's sometimes I use the command, and sometimes I just know where to look for it. So it's really
weird. All right, and it's there, and then we can move it up vertically because yeah, it's sorry. Yeah, you can confirm the height of it.
Yeah, should I just go to the bottom, or?
Yeah, I think that we will need to like manually scale it a little anyway. But if you let's see, where did it turn? If you type the command cell last, it will select the last object. Cell last, exactly. Yeah, there we can see it, and then you can use this gizmo here, the blue one.
Okay.
Yeah, you can also when you have positioned it in the z-axis like that, you can also drag this one, and it will scale 1D from the middle of it. So that and just so that it extends all through the bottom of the surface to the top of the layer, to include everything there. Yeah. Perfect. And then like Boolean operations can be quite strenuous on the processor. So while you could like do a Boolean right now, it will calculate like everything outside and inside. So what I do is if I go to top view here, or like double click there, and then you can just I can't remember now if you go from the left to the right, then I think it's include only things which are entirely selected. Exactly.
Yeah.
But if you make that like outside the box, so that objects which are entirely out of the box are selected to be deleted, because you said that you made another duplicate.
I made a copy. Yeah,
perfect.
Actually, I think the box is the thing of the box already.
Okay, yeah.
So I can just
yes.
Because it was too much of a mess when I was modeling it. But just to get rid of the things on the side, right?
Yeah, exactly. And then one has to be careful. Yeah, I think I understand that the landscape itself is locked, so it won't get. Yeah, perfect.
Because when I was placing them and then selecting it, it will always select the landscape as well. And
yeah. Yeah, but here, yeah, very good.
And should I cut those? Select?
Not necessarily at this moment.
Okay.
Because if they are partially included in the box, then it's valid to include them in the Boolean operation. And let's see now. We will first be making sure that we are. Oh, sorry. That we are. I see that the roads are here as well. What were you saying about the roads? Should we try to include them now, or?
I think we could. The thing is that these are only lines, like two dimension, like it's 2-dimensional drawings of lines.
Yeah, but we could project them to surface. So let's see here now. It's quite good that is it okay for you, Carl, if we like? I know that like if we get one road right, then we could replicate it for all of them. But is it okay for you if we just try with one set of road, like one?
Yeah.
So I guess that the dashed line, it's only like a visual setting. They are actually closed.
Yeah, there must be. Yes. I think so.
So then we can take. Let's see now, because since we moved this building over there, it would be unnatural to take that. But perhaps the one a little south of here. Like we can take this.
This
Like
road
this
here.
one. Yeah, we can take that one.
Yeah.
So to do that,
what we can also do in case is that we can have this part here, like as you said, that we don't know how it will calculate the tolerance.
yeah.
We can also say that, I don't know, talking now about the model, this part here, we put it 1 millimeter lower, and this may be 2 millimeters, and this 3.
Yeah. But before we do that, should we like because to make if I'm I don't know, like I am not for certain that it's the best way. But what I'm thinking is can you project a surface on a surface? Do you know that, Carl?
I think so.
Yeah.
At least you can project. At least you can project like a form, like a square. I know that I did it once when I had like a sphere, and then I had like a 2-dimensional, just as a square. I could project it to the sphere.
Yeah. Okay. Because that's perfect, because that's what we're trying. Because another solution would be to project the curves and then split the surface with the curves, so that you would get separate parts for the interior would be the roads, and the outside of the split would be not roads, or the landscape itself. But then like the next step in that would be like to move the split surface 1 or 2 millimeters down, but then you would have to close it again, and you would have to like duplicate the edge and then extrude that edge up to the original. I think it's like more complex. So if we can project a surface on another surface, then I think it's better.
We can try.
Yeah, because then these 2D lines, we can like if you make some lines crossing. Yeah, actually, we can, if you want to, or if it's not too much of a hassle, you can disable the views for all the layers except the roads. And or actually, you don't need to do it. You have control here. Yeah, I think you have a better view of the model. So if you make those, but make sure to make those outside of the.
Like in a way to cut it here in order to have a surface, or.
Yeah. I think you did. You can. What you do now, I think, is perfect.
Okay.
Because now we will make sure that the road stays there.
Yeah.
And then
I could have like one road from here to here to create a surface.
Yeah, to create different heights, you mean, or
if we want to try it, but we can also just go with one and.
No, I think it's good. That's like we can see how much. Then it will be like it might not be suitable for the final model, because there will be like 2 different logics. Like this is the low road, and this is the slightly less low road.
But for testing, I mean,
for testing, I think it's very good. Because then we have a closed. We can have a closed curve there. And you actually don't need to split. I will teach you something.
Okay.
Like it might be viewed as a sort of a hack, but I think that like hacks are not by itself something bad if it helps you towards your goal. And it is actually to instead of like manually splitting those lines with those lines and then joining those lines with those lines, you can use Rhino's excellent hatch command to make hatches of the surfaces that you intend to be surfaces. Because the logic is that the hatch command like it will analyze if it's a closed interior, and it will allow a hatch to be made even though it's separate lines. like not closed lines, but several which are just like this one. And then you can explode those hatches, and they will explode into surfaces. So that's like a hack to get surfaces from a not joined set of curves.
Yeah.
And it's been very useful, like for our experience, just because often these lines are not like perfectly produced, whether or not whether or not yourself or Lantbruks, it might be like very much of a hassle to make perfect closed polylines. So you can try it out now.
It's amazing to learn all these things. Like if I think about it makes such a difference once you know how to use these tricks of a program, or you don't.
It's a very useful hack, and I really hope that it works now, because otherwise it would be much advertising to but we'll see now. So if you here I would do just to make sure that you're only selecting curves, I would type in selection filter. Perfect. And then I would right click on curves. You can either have it floating or you can you can drag it over here and it gets settled there, but it's entirely up to you.
Like this here?
Yeah, exactly. And when you release it, you have it settled there, and it's it can be nice, because if you right click on, and now it's I only mean the curves here. If you right click on the curves, then it will only allow will only allow for curves.
I was gonna deselect all of them individually.
But like this is not a hack. This is just like it's good. It's good to know, because it makes selecting in a multi-object types environment. It makes it much easier. So now we can just box select. We can make it like that, or like just so that these ones are selected, and we'll try with this. So that one will need to be selected. And now I bloat the screen here. So yeah, perfect. And now when we type the hatch command, it will first make yes, this is perfect, because this is what we want. It could have had automatically made hatches where it thinks there should be hatches. And then there would be a different dialog box, and then you would have to select boundary mode. But now, since it's automatically found that we don't know which is the interior curve and which is the exterior curve of these several self-intersecting curves, do you want to use boundary? And you want to use boundary.
Okay, so
yes, and then you simply click inside of the curve. Perfect. So that is and now when you press enter, and just it can be anything, but just leave it as it is. But there you saw the boundary checkbox. Now if you again type select last or cell last, it will select the previously made hash. It's only cell last.
Oh yeah.
It can be quite confusing. Now we have the hatch selected, and then you can press explode or press.
But select last. It's amazing. It means that if you create something and it disappears, you find it again.
Yeah, it's really handy. It's very handy. So now if you click, if you type explode, it will disintegrate this hatch and make it into a surface.
Okay.
So now it's a surface. Yes, exactly. And now you see it's blinking over here, because that's the surface, and you're trying to
select something that there's nothing to select. Yeah.
Yeah, exactly.
So I should do the same with the lower parts.
We can just make sure in 3D with that selected, if you want to select that surface, just to make sure that it's properly. And if you right click on the same one again, if you right click on curves, then it will reset into everything. And that's one thing too. You can easily lose yourself in the sequence of what you have if you by mistake or premeditation, first right click on curves and then on surfaces and then on annotations. to get them all activated again, you like have to remember which sequence, or
Yeah,
I think that you can just double click on something and it gets reset as well. But it will,
nice.
if you're trying to select something which is not filtered, then it will blink like that.
Yeah.
But if you select that again and change to the perspective mode, we can just see if it. Yes, of course, it's inside. Yeah, you can hide just to.
This surface here.
Yeah, and like you said, it's a 2D surface. So it's I guess it's like at Z0. But not exactly with that over there. We can try to project it, and like yeah, both you and I have the experience of that working, but I can't remember exactly how. So if we now with that selected, if we I don't know the command, if it's like project surface to surface, or
we can try.
Perhaps it just projects. We can try project with the selected. It says select curves and points, and we don't have any curves and points. But we can still try. It's no there's no danger in trying.
Because we can try, but I'm just thinking in case what we could also do is like I don't know, probably from the surface get only the outline.
Yeah.
Project the outline.
Yeah, you can, but then if you project the outline, then we're back with like I don't know if perhaps it's the best way, but then you would
that it's not so precise.
You would need to split the surface, and then you would select the interior, and then move the interior down, but then duplicate the edge, and then extrude that edge up, so as to make sure that you still have a closed, solid polysurface model. But you know, if you like, the more I talk about this, and like you and I both have a suggestion that we share, and I think that like perhaps we can try that. So you can with this surface selected, you can type the command dup border, or a DUP border.
DUP.
Perfect. And now let's see, do you have that selected or not? I think you can press delete or hide. Oh, sorry, now yeah, you can select last, and now we have the curve, and then project that onto the surface below. Now you can press the patch there.
This
no, sorry, the green landscape.
Oh, yeah.
So we can do it again. Oh, it did.
Yeah. No.
Yeah. And then let's try then to select the surface, and then oh, sorry, yeah, I was it was ambiguous. Select the landscape surface.
Oh, yeah.
The landscape surface, and yeah, it was and then type split, or press the split button like I saw you pressing before, and then the splitting object should be
the curve.
Yeah, the curve. And then press enter. And you know, by recording history, I don't know why it's because of my mouse. By recording history, like it can be very useful when you like generatively use different commands like mirror, because then you can design something, and then you can have a mirror command, and then while recording history you can make changes to the like original geometry, and the mirror geometry also changes. But I think for these operations you can disable it, because it takes those like a series of operations into their. Oh, did it crash or?
No. It's just me. I think I clicked on the stop sharing.
Yeah, I guess that it's close to the same button.
Yeah, I have to move it.
Yeah, because like if I recommended to disable it for now, of course you will have to remember to enable it again if you use it like in your design processes. And one thing also, we can save the file, because this was a separate file, so we can, but just to save it before we do this, it's not a performance demanding operation to extrude and to duplicate border, and but like we can save it because it was oh, but you don't need to save it as another or if your workflow is like that, then of course I won't I won't
I mean,
it's good to have incremental saves.
Yeah, but it's true, I can actually override it because it's still the same one. So
yeah, I think that we have made no
changes in the
yeah. And then it should be like this now, so that the landscape is two separate parts, the non-path part and the and then we will need to actually can we just for this experiment can we hide the layer with the buildings just to make it more clear? Exactly, and because then it's important, not important, but it's interesting if this split command you had a closed polysurface of the landscape, but now it should be closed. So if we select the interior here, the path, and then move that down, and we can, I know that we have different scales in mind, but with 1 to 1000 it should be 1 meter down or 1000 millimeters, depending on it's meter scale, so it's meter units here. So move it down 1 meter. Yeah, exactly, and then we can select that same again.
This one.
Yeah, this one again. Exactly. And then duplicate border. I guess that perhaps there's like a more straightforward way to do this, but this is the way that I know like now. And then extrude curve. So EXT, is it EXTR or EXT extrude curve? There, extrude curve. It's extrude curve. And then extrude it 1 meter, not both sides. Exactly. So 1 meter up. So not like from a point to a point, because it takes a center point, I think. Yeah. Now I can select all 3 of these. So the original landscape, the pathway, and the vertical, and join them. Control J. But now record history is on again. Why was that? I don't know.
I don't know. I did not. Okay, now it's off.
Yeah, I don't know why. Perhaps it's like default sets. I don't
Maybe
know. But now let's see here. Do we have that selected now? No, we can select the landscape again, and then I think this tab is the properties tab. Let's just make sure that it says it's an open polysurface. I wonder, was it opened or closed before?
It's always open, because I have this.
I see.
It was the box is like a separate thing. I cut the box with the surface.
Yeah, actually, this is good, because the height of the box it will be used, like what we input into Fusion 360 will be as closely resembling to the final fabricated model as possible.
Okay, yeah.
Now the box is as I see it, it's split across with the patch, but they are not joined, and that means that we still can have like we can still very easily if we select it and
change the size.
On, we can change the bottom height and the like. I am not questioning it. I am just simply asking: is it what you intend?
No.
No. Okay.
In a sense, no. It's just the thing is like then for the final product, the question is also what size do I take? And here, having the water coming, this will be the lowest point.
Yeah.
And it was like maybe depending on the material, but I guess there must be at least 1 centimeter, maybe even 2 of space that it doesn't break apart.
Yeah, I understand. Yeah, of course, it depends on the material, and I also see here, as you say, with the water being, it should be like a very thin, or not that it should be, but that's a weak point, and you of course want to have that extra height that you said.
But this now, the size of the box is random.
Yeah, but I think that we should, for the experiment, we should like settle on a height that it might be random, but it should be like something we test out, because we will, of course, it could actually be at this moment also that we like, because the toolpath will be authored with respect to the material stock. And the material stock you actually have at hand. You have the wood block.
Yeah.
So we could measure the height of the wood block, and then decide upon height depending on that.
Yeah.
Because it can be self-evident, of course, but if we here in Rhino have a very thin model, and intend it to be thin, then a lot of material will need to be removed above so as to make it thin. And equally then, if the model here in Rhino is very high, then perhaps the material stock that you have chosen is not sufficiently high to model it at all. So I think it's good that we can measure the, if you have a perfect.
I was scared I wouldn't be ready, but I think it was actually quite okay.
It was really nice that no friction of time.
Yeah. So we're talking now about 4.8 centimeters.
4.8 centimeters.
And of course, my goal is to take away as less material as possible.
Yeah, I will just enter the calculator here. So it was 48 millimeters.
Yeah.
And then I'm calculating the maximum here. And like and I know that actually you have already stated that you want at least 1.5 to 2 centimeters.
But I think for the trial we do tomorrow, we can just take the piece that we look at, and then for the final one we can look at the full one.
I totally agree. I still think that it could be valid to like calculate a maximum, so that we know the maximum, so that when you come to a final stage, that you if you then like model in Rhino something that would be like 52 millimeters high, then you will know beforehand that it's not going to work.
Okay, to be like aware of the.
I mean, I think it's and also it's like part of the process. So I would suggest that we do it now. It won't take that much of time. So the material stock is 48 millimeters at height.
Yeah, I did a little error. I deleted the highest house. The highest house were on this very corner.
But that is not a problem really, because what we are solving now is like the maximum height that we can input, and like you said, this demo model, it will be of a different height. It will not necessarily be the maximum height, and like I know that you said that you wanted to have like as large a thick support underneath the river, but we can like I would say that if the highest house is higher than the maximum allowed thickness, then I would rather like make that a little thinner underneath and allow for the house. But we can this stage of the process is like what material you have for now. Perhaps the final model will have a different material stock, but what we have now is a 48 millimeters thick material. And I will now I can take aside the thought of the river and just like enter the like what I have in mind. It's 48 millimeters, and no matter what material we are milling, or perhaps it's actually, if it's styrofoam, which is very porous or like very easily deteriorating, it should be more than that, because you don't want anything to enter the vacuum inlets. But that was a parenthesis. With 48 millimeters of material stock and with wood, you want at least 3 millimeters. If you're not cutting all the way through, which you will not, since this is like a landscape model, a height field model, and you will be contouring it, but you will not be cutting a contour for the full depth. If there are any like fringes on the side, or fringes I say, but if there are any material stock left on the sides outside of the actual model, but like with still unmilled wood outside this model, then it's recommended to take that final model and go to the other machines and like very carefully saw it out. So that because otherwise, if you're cutting all the way through, which you of course can, but it's not necessary for this model, you will have to have a spoiler board underneath. And the spoiler board is just a thin sheet of MDF, and it's equally unproblematic. Then you cut all the way through your material stock, but not through the MDF. So the MDF, the spoiler board is like the maximum depth. But then when you cut all the way through, you always have the like it's paramount then that the suction, because then you have like you will get individual parts of your material stock, and it's very important then that your material stock has adequate suction underneath every separate part. So therefore, I will make sure, but I will have the assumption that this will be milled without a spoiler board, with it laying on the machine bed, and then it's important that we don't cut closer than 3 millimeters to the machine bed. So I will take the 48 millimeters of the material, and I will.
If I might just quickly ask, it's interesting. The spoiler board. Imagine now we would say I want to use the spoiler board. Would I have to glue my piece to the spoiler board in case to have the suction?
In this, I worked in the CNC room this morning, and the same question, and it's like when you have seen the power of the suction of the vacuum machine one time, you like you accept it, like of course it's stuck. But the thing is that the vacuum is really powerful, and MDF is quite a porous material. It lets air through quite easily, and since it's only like, I don't know if it's a 2 millimeter sheet or if it's 4 millimeter or somewhere around there, but the spoiler board, it makes sure that you're not cutting all the way through to the machine bed, damaging the bed, but it's actually allowing for the air to it will create a great suction anyway. But it's important that even though it's creating a great suction, like even through the spoiler board, of course the suction is reduced by a non-insignificant amount, and additionally, if you are cutting through, which perhaps you are if you're using a spoiler board, then you have to make sure that there are 8 vacuum inlets on the machine bed, and they are positioned like in a proportionate way. But you will have to make sure that if you're cutting through a material and it will get 2 separate parts after cutting all the way through, you will have to make sure that you have fully enclosed sealing with the vacuum sealing strips for both parts, so that they stay at the same.
So it doesn't then one would fall off.
So that's very important. It's you will see tomorrow that the vacuum suction, you and I will both try to make the material move, and we will not make it because the vacuum is so strong. But that's also one of the ways why we always leave 3 millimeters of material stock, so that there is no risk of I said that with styrofoam the risk is greater, so then you would leave more, and also perhaps not apply as much suction, because you don't want material to like actually lose, what do you call it, like you don't want the suction to suck the material down the vacuum inlet.
Okay. Yeah.
But that is no problem for wood as long as you leave 3 millimeters. Then it's no problem. Like the spoiler board proves this as well. So all right, then we have a 45 millimeters, and then to get a nice surface finish, me and Letizia, we have made a lot of tests about this, and we have found that if you leave if you make sure that it cuts 0.5 millimeter, then Fusion 360 might not deem that an amount enough for cutting. So I would say at least 1 millimeter of the top material should also be milled. That's 45 minus 1 is 44 millimeters. So from a 48 millimeter material, we have 44 millimeters left to actually have the model like positioned inside. And that's about it. So now we have made sure that 3 millimeters are left on the bottom, and we have made sure that 1 millimeter is millable, or like is actually milled over the model. So thus we have 44 millimeters left. So that we need to know that if we make a bounding box on all of this with the box included, then we can like very quickly see if it's more than in this scale, and if the final scale should be 1 to 1000. If this would be more than 44 meters, then we will have to adjust the size of the box underneath. So as or pick another scale or have another material, or so Carl, could you do that if you select all of this with the box as it is included now? With it I think it's
the box is not
and then if you do a bounding box command, then it will give you one, if you press enter to confirm the options, then we'll give you one bounding box which contains everything. And it says here that it's 131 meters in Z height. So in 1000, it's way over what could be milled on this material. Because in 1 to 1000, it should be no more than 44 meters. But then we know that like this box has a lot of extra space, and this I see here as well. I don't know precisely what is, but it extends a lot there. We could.
It was just in order to make sure that it's fully in the ground. I just extruded it.
Yeah, but like so as not to get fooled by the bounding box command. Now I think we can delete this bounding box and know that we will have to. Do you think that we should, because we will sooner or later make a Boolean union with only this, like we have previously prepared for, but we can still keep the landscape as it is as for now. If you look at this in the right view, or in like from the side in an elevation viewport, I'm just going to check if. Yeah, I can see that the highest point of the elevation is higher than the height of the highest tower there. So we might, and of course with the buildings, like you said, there was a building on the top. It will get even higher. So I don't know if it's suitable now with those buildings deleted to like be aware of this, that perhaps 1 to 1000 is for this particular. You said so already that you are like prepared to glue several pieces as well. But then I said it on the email as well, and I don't want to like, but it's repetitio est mater studiorum. Repetition is like the mother of knowledge. But I will. It's if you glue sheets in a vertical manner, since the CNC mills in a like a horizontal layer manner, then it's not that much of a problem. It's like you should be aware of, like, if you happen to have a pass which is co-aligned to the glue layer, then you will have like a not very nice looking layer, because the glue is, of course, it might burn, not burn into a flammable thing, but it might not be producing such
from
an
aesthetic. Yeah, but
yeah.
I didn't quite understand when is it more of a problem and when not?
Oh yeah, if you glue it like this,
then it's fine. And if you do it on top,
no. If you glue it like this, it's fine.
Yeah.
Because the whole the 3-axis CNC moves like layer per layer. So if these now for 2 layers or 2 sheets here, these 2 sheets, if they are adequately glued, it's unproblematic that they are, because each sheet will be milled like one horizontal layer at a time.
Okay.
But if you do like this, it might be more problematic, because if the toolpath happens to be like in the border there, and you know that like it's much easier to brute force with your hand, like 2 glued sticks to just like if you have one foothold, or what you say, you can break them apart. But if you have 2 sheets with a lot of adhesion surface, it's much harder. But I won't say that it's like impossible, and I would not even say that it's not recommended. Like, if we are aware of this, and if we glue them adequately, and perhaps also be very like careful in the feed rate, and we will be supervising this. But if you intend to make such a glue, like a, I don't know if this is horizontal gluing or a vertical. If you want to make that for the final model, then I think it's good to test that beforehand as well, just to make sure that it works, because there's a lot of the spindle moves very rapidly and with much power. So a lot of lateral power that actually wants to like get rid of the material in a lateral way, while there is not as much vertical pressure.
Well, one thought, maybe it's really unsure, but I was thinking, could you also do it with CLT, cross-laminated? Cross-laminated timber, like it's industrially, like you would have the same thing, that you have this horizontal gluing, and on some parts of, like, you have the combination of horizontal and vertical. But usually it's industrially made.
I would say that as long as the individual elements are properly glued, I would say that it is not a problem, but one has to be aware that that would be the weakest link, or like so not to like test mill a single element and think that, okay, this toolpath is like problemless, and then in the final make it like that, and we will be aware of that. But you know, Carl, like if you find any material that you want to make the final model in, like we will of course try to make it work. And I just want to like be open with the additional layer of security that has to be applied when using those solutions.
Perfect. I'm learning a lot. So
it's great. That's the purpose of this. Okay. So because I think it was 144 meters in Z height, the bounding box, and if you divide that by 1,000, it's 144 millimeters. And that's too much for this material. But we also see that you have a lot of perhaps like not necessarily that much of height for the material there.
Because what we could do actually maybe is I don't know if it's take the box that we previously made, and maybe cut away. I don't know if we can cut away all the terrain.
I think that it's
and then make the Boolean.
I think it's time to do that. So we can show that we yep. And now we can actually do this with only the landscape for now. And you know that there is Boolean union, and there's Boolean difference, and Boolean intersection. But there's also the Boolean two objects. And when there's like, because when you union something, it's pretty self-evident that everything, that you want to make everything into one. When you subtract, it's equally self-evident, like you want to subtract from this. But now when we want to make an intersection, and actually it might be like equally evident that we can simply make an intersection. I was going to make the suggestion that the Boolean two objects is a nice command, because that lets you see the results of different interpretations of the differences of the intersections. But now I think this is a straightforward Boolean intersection, because we want to get everything that is both contained by the box and that which is the landscape. So before a Boolean operation, like, it's good procedure to always save, because they themselves take it's a strenuous operation. It might take time, might crash. So but then it should be nothing else than to select the landscape. The landscape is not solid, isn't it? It's not solid yet.
No, it's not a solid yet. Should we make it?
Yeah, we should make it. And now I see that we have like several parallel processes here, because we have made the road, and we should make it a solid, and we should make the Boolean intersection. So we can begin with. I think that the road is joined. Yeah, I think that's already joined.
We have one. Yeah. Now the question is, we can also do the two others, but we can do it before or after?
We can do it after, so as not to have four processes like laying in order. I'm very much yes, Sophia jokes about it, and I'm totally aware of it, that I'm a serial person. I can do one thing at a time. And so let's begin with making sure that this is a joined polysurface. So if we select both the box and then just join. And now it says that it's two open polysurface. No, it says one polysurface. What was the other?
It's an open. Oh,
it's okay.
Because there's no.
But that would be. Okay, I see that it does have some sort of bottom, but the bottom is.
I have to make it. Like, I probably I don't know, at some point deleted it.
Before doing that, you see that this looks like there's actually a plane there. It looks like it already has a bottom.
Could be that there was one, and then probably I once extended, or like I don't know, must have done.
I would undo that join command, so as to make sure that like what we are joining is.
I think it's not joined actually.
Oh, okay. No, I see it. It's just, but it says that it's a box, but it looks like a plane. No, it's a surface. It says surface. All right. Yeah, we can just either we can move that and join, or we could just cap the one, but we can join that.
Now we have a closed polysurface.
Perfect. Great. Okay. Second line of order. We can then take this box and do an intersection. So now it's time for the Boolean command that we can save beforehand.
So I select the box.
We select the box, and I think that either with the box selected or the landscape selected, we can type Boolean intersection. And that's the first set was the box, and the second set is the landscape. So we press that and then just enter, and there we have it.
Nice.
Yeah, and it was quite quick as well. So I have this prejudice about Boolean operations, that they take an awful amount of time and that they always fail. But this one went flawless. all right, one thing that like was not perfect was that we lost the bounding box. But
Yeah.
that is not a problem. Either we can like undo and duplicate that beforehand, and or change the settings so that it keeps the copy of the Boolean set. But we don't need to do that. We can just select this again. The precise, yeah, the sorry, yeah, this where you select this and then just type bounding box and enter and select last or select it manually. And then we can you can drag that gizmo so as to extend it there, and now we have like it again.
Okay.
Good. And now we should do the same thing with the but
building.
Actually before doing that, I'm wondering if it's the best procedure to first join them all and then to make the Boolean intersection again, or if it's better to do the Boolean intersection first and then Boolean union them. We can try either way. What would you prefer to try? We can test both if the one first.
Let's try to join everything. I mean, I think the joining everything together and then doing the Boolean is probably the harder one, because then he calculates with more things.
Okay, so
instead of all the buildings, but we can just try. So
yeah, let's try the other one.
I get to see if my processor is with me or not.
But then we would need the box that you deleted. We would need that again.
But don't we first join everything without the box?
Oh, but did you? Oh, you want to try the one you think is most like performance demanding? Okay, sorry,
yeah.
I misunderstood. Okay, yeah.
As a test, it's like so not. Oh,
yeah, and then you can just, if you left click on the curves here, if you left click there, you can deselect the selection of curves, because then there will be only. I wonder what the surface is here though. You can left click on the surface here as well, and then that will not be, because now we only have 20 polysurfaces. Perfect. And let's try to Boolean union these. And it failed. And one nice thing about Rhino 6 is that you actually can see where it fails.
Okay.
Yeah, and it was here. And if you press that info or that exclamation mark and the text dot, it says, and it says, what does it say? Intersection curve ends at a non-manifold edge. Okay, so that non-manifold edge, that means that it is an edge or a part of a surface that is inside a solid.
Okay.
Which you like in a definition of volumes that cannot be interpreted as anything. It's like an error that is valid because one solid object can't have a part of itself intersecting itself, or like inside itself.
Okay.
So to fix that, yeah, I think that like the first thing to try, if the tolerance of the project allows for it, is to simply like shift it a little to either side.
Like this one, to shift it a bit to this side.
Yeah, you can try it, because you can like try to if this is in meter scale, you can try to shift it like with 0.05 meters. So just is that 5 centimeters? Yeah, I think so. Yeah. So let's try.
Maybe a bit more.
I see.
I can also try to first do the union Boolean between the two of them.
No, okay, they failed even after doing that, because then we will be doing yeah, you can try that, but I think that a better solution might be to like fix that non-manifold edge.
Yeah.
So if you can like undo so that it's in the original position, because this clearly is like it's sometimes the Boolean command is due to tolerance, and then it's easy to just shift a little and it gets okay. But here I would do like this. I would take that single volume, or like that problematic volume, to this L-shaped, and then I would like, just to be able to see it a little better, I would move it in the x-axis
Should I isolate it?
Yeah, you can isolate it. Yeah, sorry, I think in Rhino 5 isolate was really problematic. Like
Okay.
I would not touch it because it failed to re-show everything else. But I think in Rhino 6 that's solved. All right, and then with this selected, if you select this, and perhaps in ghosted view should
yeah, it's probably better.
If you select this.
Oh, yeah, this part here.
Yeah, that's like it's inside the solid, so
yeah.
It cannot be like interpreted what is inside or not. So if you select this and then press explode or type explode, and then I would either with
delete them or
I would like if you can maneuver so that the camera is inside. It might be difficult, but yeah, like this, and then I would remove, because this is a non-manifold. As you see, it's like part of a solid, but that has certain edges here which are not.
So now it should be fine.
I don't know if you join these now. So if you select all and Control J join, it says one open poly surface. So we can undo that so that it's still exploded.
Not exit. Oops.
Oh, yes, good that it had that confirmation or like that. Because in a command line interface, if you press exit, then it's just like I would do like this because this is.
I'm just. Oh no, this is not open.
I would do like this to simply, perhaps it's a little tedious, but it might be good to sometimes make the tedious work, because then you make sure that because the more straightforward way would be to like try to guess which of the surfaces are problematic and delete those and then try to join everything. But now we can do like it's like we can if we zoom out a little bit or like have it in view, we can like select two of the objects, Control J, and join them, and then a third, and then like until they are so joined from the outside as it is a closed object. And when it is, I hope that it will be, and otherwise you can try to cap it. So
you can start like with these the roof
start
and
with the roof and join it, and you can press Control J. That's like the short command for join.
Okay, so and then
yeah, and like you see, even though in the beginning it seems like, oh, this is a lot of work, but like the more you join, the more satisfying it gets to see that.
That's true.
Yeah.
So this should be. I think that the problematic part will be there. So
yeah, we can try with like join, like you say, join everything that we think is not problematic. Okay, and now this is a suggestion, and you are. But even before suggesting it, I disqualified it. But I was going to suggest that now, since we both suspect that this like thin strip on the far end, that it's problematic in some way, and that we can exchange it, or that we can remodel it. I thought that we could like if we with this open polysurface, if we type in the command
cap or
solid PT on, solid points on, then we can like shift the far end to this, and then we can keep the topography, we can keep the topology of the surface model, but shift it. But if you do that for this surface here, I think that this surface here might be unproblematic. But I was suspecting that perhaps that will make, because these surfaces are like, in a good way, they are quite uncomplex. They are like, what do you call it? This, they are planar. They are planar.
Yeah.
And if you show what is called a solid PT on. If you use solid points on command and then shift it manually, then I know that for some of these planar surfaces might turn into non-planar surfaces with really complex topology, and that I disqualified before even suggesting. Do you think that we should try to join the last set of surfaces as well, and then instead of joining those that are inside here, that we simply cap that open end?
Yeah, I think what we could do, because I think it looks like I did the building and then I extruded it for like the building itself kind of ends here.
That could be why the non-manifold edge was created.
And that part of it was inside. But I'm thinking, what if we cancel like this part here that is not joined?
Yeah.
We can actually even leave it, or just leave.
One thing we could do that will not produce a non-manifold surface is that this is an open poly surface, and as such it has a border. So you can do a duplicate border, DUP border.
Yeah.
And then you see here that this is a problem. This is where the actual problem is.
Okay. Yeah.
This was not it was not the outcome I expected, but this was better because this was in troubleshooting wise. We see that the problem is actually that it has an open border between these two, and why I don't know. Like in the roof here. But to fix that,
should I explode it and maybe redraw one of the roofs?
Yeah, I would perhaps not even redraw it, but let's see here if we can make it. If you do explode, and then with everything now they are separated. But if you undo that last thing, so that it gets joined again, and then if you explode it again, and I will tell you that then everything is selected, but they still. They are separated, but everything is still selected, and then you can just control-click one surface and then join again. That's like because sometimes due to tolerance issues and like one can solve difficult problems by just iterating, like exploding and joining and exploding and joining with one or two surfaces less. So we can try that. So with this open polysurface open polysurface selected, if you press, I think you have to press escape.
But should I select it, or?
Yeah, if you select it, like but only the polysurface.
What do you mean?
Yeah, sorry. If you select like if you click here, so to select only the polysurface.
Yeah.
Then we have an issue here.
Yeah.
So I think that we perhaps could delete this or like leave this out of the calculation. So to do that in an easy way is to now press explode or type explode.
Type explode, okay.
Type explode. And now everything is still selected. So now it's really easy to, with control, if you
hold, to deselect it and join it again.
And join it again, and like
that's nice.
For some problems, like exploding and joining is an easy solution. But I know that selecting all those individual surfaces again, that's not like one solution I don't even want to think about. So, but now we have this, and I think that you can do it any way you want, but the way I would do it. What were you saying?
I don't know if it works because I discovered the cap function.
The what?
I think cap, CAP.
Oh yeah. That's what we're going to use.
Okay.
But I don't know if we should use it for this surface, which was.
Because I'm wondering if everything else is fine, I should be able to join it. I don't know if it works. Join it and then put cap, and then it should close. No.
No, because
Okay, no.
there's a non-manifold surface there, or non-manifold.
Oh, still.
I don't know if it's still there, but the
That was
the topology has this error.
yeah.
So what I would do is let's see here now, because I understand that like pinpointing this is, if this is truly planar, which I think it is, it should be no problem to cap. But we will see about this. But if you select by right dragging like all of the all everything else, like, but not the, or you can select everything and then just control deselect the poly surface here,
like this.
Exactly, and then deselect the poly surface with control, exactly. And now let's delete this for the time being, because you see that there is something we don't want anyway. And the curves here, they were not deleted because we were not having curves there.
Selected.
Yeah, it's a two-edged sword. It's like very, very handy to have, but also easy to forget. All right, because now I think that it would be fairly easy to make a surface point, like a surface from points. Let's see here. Clear 1, 2, 3. Yeah, perhaps that 1, 2, 3, and then 1, 2, 3, 4. I know that the topology might seem a little off, but then we can cap the rest, and I think that it will work. We can also if you don't do that, we can instead make the same command, srf pt, surface point or surface on points, and pinpoint precisely that, and that, and that, and then it should cap all of the rest by itself. We can try that.
But we can. What was you said, to make a surface out of 5 points?
We can't make a surface out of 5 points, but thus we should divide it into one surface of 3 points, and then one surface of 4 points. But that, I think that Rhino will produce a better topology if we do this roof, or like this pitched roof, and then try to cap it, or the
So surface points, right?
Yeah. Oh, sorry, SRFPT. So it's quite confounding that some of these have this really shorthand writing, and yeah. And then just make sure that I will just initiate a process here on the other computer. I'll be back in a minute.
Sure.
Okay, did it not cap, or
it did unable to cap one object? The opening did not have closed planar loops of edges.
Then we can make the like the surface point again and take 1, 2, and 3. Let's see now. I mistakenly there.
Should I delete the roof again, or no?
We can try to. We can. I think that since you made this manually, it should be perfect. But you can always, if you select it and dupe border, then you can see if it creates a border in between there now or not. No, now it's good. But since this was not planar, if you make planar surface, or if you type planar SRF, or if you click the planar surface, it would say the same. It would say the same as with the cap, I presume. Since if it's not planar, then it will not. Let's try it for the sake of it. If you type planar SRF. No, exactly. They are not planar.
So I will do it manually. Maybe a quick question. What exactly is planar, or like planar, the definition?
Yeah, the definition of planar is that the surface of 3 or 4, actually it can be n amounts of points in the surface,
Okay.
All are in the same. It doesn't necessarily to be in the same Z position or the same Y position or the same X position, but that there is no difference in curvature, or what to say. It's like totally flat. A planar surface is it can be rotated in any way, but all points are co-planar. All points are on a same theoretical plane, no matter the rotation of it.
So if you have 3 points, you always have a planar surface.
Exactly. That's the good thing about. That's why with video games and with rendering engines, everything is triangulated, because that's the only way that the rendering software knows that like each individual triangle is positioned exactly where it is, and then it's all a lot of smoke and mirrors to make it seem not
to be triangular.
Yeah, but that's another that's another topic. All right, if you join these, there's some curves here, but it says one open polysurface. So let's see if you dupe border this. Okay, it's I don't really know what was the problem with that now. But I saw that it was only like a small. I think this could be an opportunity if you get rid of the curves. Like as an example, if you right-click on curves and select everything and delete, just so that they don't. And now, if you select this open, if you right-click exactly, if you right-click and then if you right-click and then left-click.
Okay,
that's it's quite. But now, if you select this polysurface and it's open, then you can do like this. You can explode by typing explode, and then Control J to join, and let's see if it's still open. No, it's still open. Okay. I was hoping that would be another hack, just to make with the tolerance make it. But then. Perhaps I know that now we're dedicating a lot of time to making this work, but this is very much of the preparatory work to make everything work for Boolean operations, so that the model can actually be interpreted.
I'm having a great time. I'm learning a lot. So
yeah, I'm glad. I would say that.
Should I redraw the bottom and or
you decide if this is a good idea or not. But since we now have an error that is here under, some way somehow it's not either it's not planar or it's open in some way and it doesn't come together. But I assume that the bottom here is completely flat, at least in design, or
it should,
it should be. Then we could, and I say you decide whether this is a good suggestion or not. But we could make a plane, like just a quadrangular plane, co-aligned to the Z plane, or to the to the XY plane, of course, co-aligned to the XY plane, and then we can move it up a little bit so that it is somewhere around there. I now when I made and then we can split all surfaces, or all surfaces. We can split the open surface with that plane, and then plane,
extrude it.
No, we don't need to extrude. Oh, well, of course, if we need to extrude it, then we should.
Yeah.
But then we would be certain that since we split the surfaces with the planar plane, then we are 100% certain that it should be planar. Then it would be not a problem to cap it. But, we solved this non-manifold thing there, and we solved that. But since this is still giving us a headache, then we can do like that. It's not an insignificant work, or but it's still. I think it's quite an easy solution to a problematic problem. So we can make a plane either by typing in plane, or perhaps there's a button for it. And then just
random.
Yeah, it could be of any size. Hey, Manfred. And then just move it.
I think I'll just make tips.
Hey, Manfred. Yeah, and then we can move it down. It can be even further down, I think.
I can also like put could I also put like a dot here, so I can cut it now and then I can extrude it to this dot?
That's perfect. That's really good.
Okay.
Yeah.
So
we
now
take that and split it with the plane. And then now with both, oh sorry, but like also like with the explode, you can. But now this is not but you can also control click to like only deselect one part. But now since this was two parts, it's like the equal amount of clicks.
Okay.
Yeah. So we can select that and delete, and then select the one above, and just type cap. And it's one closed polysurface. Mission accomplished. Nice. And then since you made that point, it's easy to extrude, and you can extrude that face to that point. And let's make sure that it's still a closed polysurface. Yes. A closed solid polysurface. I'm starting to mumble a little, but a closed solid polysurface. Perfect. All right, then we can unisolate, or
and now it should work.
Now it should work. Let's see if it does. So you can.
Now we have this little gap because we took away the extrusion, but this should be fine.
Yeah, you can extrude it if you want, but as I said, no tool will be able to get in there, so the simulated path will not allow for such a gap to be milled. All right.
Now
we will need to. I don't know if it's necessary, but we have one surface, and I don't know if was that the plane that we. You see that we have one surface, and I don't think that the curve will be included in the Boolean, but I know that the surface will try to be there. Oh, it's okay.
I deleted it.
Yeah, I thank it. I thank it. I think it's fine.
So Boolean, unique Boolean.
Yes, it actually did work, and it broke history.
Oh, my history! Damn, like this is not possible. I will try.
I think that it was disabled.
Yeah.
So perhaps it's like on a per object basis that. But I don't know about this.
But I might be able also to. I will check the settings because I'm sure I can disable it. Like.
Yeah. All right. So now, did you keep the bounding box of previous? Because now, if we do a bounding box of this, it will be too large because it has.
Yeah. I don't think so. But what I usually did before I learned about the bounding box, I would just.
Yeah, make a rectangle. Yeah.
It's more clicks, but it's.
Yeah, and I think that's also. With the bounding box, you always know what you get is precisely the bounding box. With the rectangle, like it's susceptible to human error if you click on some.
That's true.
But if it works, it works. So it's, all right. So then we can extrude that. Or make a planar surface first, depending on. Either you make a planar and extrude the surface, or you make an extruded curve and then cap that.
No, it's curved. Just extra.
Yeah, but it's confounding with like when there's two ways to achieve the same goal, and then it's just. Yeah, perfect. And this will be interesting because you see that they are like perfectly coplanar. The the side, the surfaces, what do you call it, the faces of the cube, or the bounding box, and I will call it bounding box by by what do you call it, by routine. But the face is coplanar to the landscape, and this might prove difficult for the Boolean operation to achieve, or like to interpret, but we'll find out.
What I'm wondering, could I also take this and make it split with this curve?
Yes, and as long as that curve or as that box from the curve is totally planar, which it is because it was a rectangle, and a rectangle is if extruded, the faces will be coplanar.
Yeah.
So that would work as well. I don't know how the I am not certain enough to know beforehand if a face that is coplanar to another face, if the face is split by that face, if it will like turn out okay or not, or like if it will accept that. But let's try. We can try either way. You can either split it, and we'll see.
We can try once we split it, so we see.
Wait, with yeah, okay. Oh wow! So if you split it with a curve, it gets projected in the cell.
Yeah, I think it's always splitting it with depending on its planarity.
Yeah, planarity. Okay.
So it's actually a very similar result. I think
that's
good.
That's really good. I learned that today from you, so that's really good. All right, we can we can delete the bounding box, or and then we can try if we cap this, it should be fine.
Oh, that's maybe the difference, is that now here we're missing the but by splitting it, it's not closed anymore.
No, but we cap it now, and since it should be planar, all the openings should be totally planar, then the cap command should be
okay. Let's see if
no, okay, then I would undo this and try the other way with the bounding, with the Boolean operation. But
undoing split,
yeah.
So Boolean difference, right?
Not Boolean difference, because that would only leave what is that would only leave like what is outside of the bounding box.
Okay.
So but if you make a Boolean intersection, the next option, then that should be, because then it only keeps what is inside both volumes.
Yeah.
But now it's important to, because now you accidentally selected both as the first set, and you need two different sets.
Okay.
So if you do that again, but then only select the bounding box.
So the first would be the bounding box.
It could be anything. The Boolean intersection is like it doesn't matter which one is the first one. They will.
So if I select both of them as first one, he will treat them as two different.
Yeah, because then Rhino would expect you to select a second set and then make an intersection with those two.
Okay.
But we will see how this works, because now, as you see, the orange face is coplanar to the gray face, and I don't know how it will manage that. But it seemed to manage it very well. So I think that this looks really good, and I'm excited here, because this is like, of course we will like put it in the correct position and everything, and perhaps adjust the height of it, but this is what we will input to Fusion 360. So I just want to be clear with that this is like great achievement.
Okay.
But still we have the issue with if you select this and make sure that it's a closed polysurface, but I think that it really is. No, it's non-manifold. You see that? It's a closed non-manifold. And to fix that, I would like first hand, I would just like rotate around and see if the topology, you know that all individual surfaces, even in a polysurface, have these iso curves, and these iso curves, they show the the curvature. So here for the landscape, you see that the curvature or the iso curves are more dense because it is undulating more, and the planar curves, they are just with a grid, or like they only show one iso curve from the middle of its untrimmed surface in the middle, both axes. But I don't see any, it's not anything that I see like here and now, but we can try to, if we select this and explode it and then immediately join it again, then we can see it if the Boolean operations made it non-manifold. That is, it's not like a closed surface with every surface like have an outside and an inside, and not that something else has both an inside and an outside. But we can try to select it and then explode it and then join all the individual surfaces again. So now we have 348, one closed. That was that. So
okay, so
that
that's
is one
just
thing. Yeah, I don't know why. I guess why, but perhaps McNeil and company haven't. I guess since it happens often enough for me to presume that this will fix it. And I guess that it would be like automatically fixed if you like after a Boolean operation, explode and join. But that would of course take more time if that would be like
within the command.
But
okay,
if it's non-manifold after a Boolean operation, it could be like sufficient enough to just explode every surface or explode it to individual surfaces and then let Rhino join it again. All right, because now we have a closed solid poly surface, and that's great. But if we make a bounding box of this, we will just have to make sure that the height of it is, because I guess that this still is more than 44 meters in height.
Yeah.
One would assume so, because it's just a really large like bottom part of it. So and if we just press enter, you can look here, it says 121 meters. So we would we had a maximum material stock allowance, or what you call it, maximum allowed Z height for the material
of 44. So if could we go now, how is it again, how do I do the outside thing again? How do I get the same exact square as it is here? Like I could do right. Okay, I could do as well. No, maybe not this one. I could do this here like this. But you had like another command that you dupe.
Dupe border or
dupe border.
Okay, but then dupe border only works for surfaces which has a border.
Okay.
But you can like do it easily here by I would then the command extract surface. Thus you can extract one individual surface from a poly surface, or a box in this case. So okay, extract surface, and then you have the option either to copy it or to extract it, and now it will be extracted, so it will like be removed from the box.
Okay.
And that, if that is,
it's like, so then it's like if I would explode it, deselect it, and join.
Exactly. Okay. But with that one deselected. Yeah.
So if I do this,
now it's a single surface, and now you can dupe border, and then you would get the exact border of that. So,
but now I could also extrude it in one direction.
Yeah.
And exactly 44 meters.
Now I understand. It was nice because I was like in the darkness, but now it's a really nice way of doing that.
And now I know this is what I can actually.
This is what you can actually mill. And if you find that you are like it's precisely 1 millimeter that you're missing, then if that is valuable enough to you, then of course you can skip the one thing about the top surface, that we that we set we will mill 1 millimeter of the surface material, so that the model itself is like fully milled. But you can always like let the top of the model rest at the top of the material stock, then it won't get milled at all. and will produce a different surface, of course, if it's a material that
but in our case technically we don't need this 1 millimeter, right? Like hypothetically,
but since this is just a point, it will still like begin to you are correct in that perhaps like 1 millimeter below that singular point, or like that.
Because I'm thinking if this would be the max height, like if these buildings here, then of course they would be like the surface wouldn't be milled. Because like imagine if we set the point. I mean, if these buildings had exactly the same height as the tower, and like having, as you said, like having this 1 millimeter, we make sure that the roof is milled as well. But and if we say, okay, we do not care about this 1 millimeter, then this roof is not milled. And then the question is like, what's the effect on this? Like, will you see something or not? You might see a tiny bit, maybe.
It's and that's one of the drawbacks of the Fusion 360 workflow, because you will not have total control over whether that will be like what you intend to or not. Previously, when milling and like the toolpath can produce like a small island of unmilled material, and which you of course can manually like sand away after. But this is something to like we can test it out either way, either with 1 millimeter extra margin or with 1 millimeter not.
Should we test it out? I was just thinking I could copy the church and have two churches and one a bit higher, but that doesn't work anymore.
No, but technically you can, if you save this model, and if you open the other one, you can select that church and type export, or go file, export selected, and you can export that singular church as a different or as a separate Rhino file, and then you could import it here. And Boolean units. I don't see the like it's workflow wise it's not a problem. We could do it now if you would like to.
Yeah, sure.
Yeah.
So this is saved. Oh, I should have left it open.
It's fine. I think that it takes some time to open Rhino, but it's not.
So housing. So going here, and then
File export selected. And then you can file and open. You don't need to close it now, because you can file and open. I think it's open recent.
All right.
Yeah. Which one is it of these?
This one. Okay.
Right. And then I think it's insert or import. Which one do you think? I think it's insert.
Let's try there.
Perhaps not, because this is
no, this is for the blocks.
Yeah, for blocks. So it's import, but then I would guess that it's import.
Okay. Wow.
Yeah, and it was in the same place, but perhaps that's not the best circumstance for experimentation.
So it means that we could say now our box, I know we haven't made it, but if we say we have our box, which is 44,
yeah,
I could just move the church like a bit, maybe in this corner there.
yeah, and then move down that, or what did you
Up.
expect? Move up.
Because now with the bounding box we have now, with the gray one, no, not the gray one, with the extruded, yeah, the gray one, we have these. Actually, now I'm thinking, do we have too many boxes? No. This was the one that we made, which was 44.
Yeah, I think that's the correct one.
So 44 was respecting the 1 millimeter.
Yeah.
So if we decide not to respect it, we can just move this church 1 millimeter up, or 1 meter in reality. Yeah, so this idea was, if I go 1 meter up,
yeah,
technically now we're out of our bounding box.
Yeah, exactly. But that was the one thing that is confusing me, because one cannot go beyond the bounding box. But we will make another bounding box where that is that will not have 1 millimeter of. Yeah. So you are perfectly correct. So, but I was because in Fusion 360, then you will assign the bounding box as not the imported bounding box, but the calculated bounding box from the model.
Okay.
You will define that as the material stock. And thus it would be unwise to have a smaller material stock than the actual model. But that we won't have. It's just we will experiment with different. So we will have one in Fusion 360. We will define it so that the bounding box is perfectly aligned, or precisely at the point of let's see,
start.
Precisely at that point. So 1 millimeter up.
Yeah.
But that was so. But if one would do as I thought in my confused state of mind, to take 1 millimeter down, then one would have 1 additional millimeter of margin, which was not the intention. So you are perfectly correct.
Okay. Should I go and intersect both of them? So, our because this is way too.
Yeah, it's way too. But I would first. Boolean union the pink church or the magenta church with the rest of the model.
But then I have to make a new box.
Yes, exactly.
Okay.
Yeah,
that's good.
But that bounding box will be 1 millimeter higher.
Yeah.
So we are 5 millimeters. So it's you understand why I got confused.
Yes. Okay.
Great. And then a bounding box.
Oops.
And then extract surface or extract face. Was it extract surface? I think.
Surface.
Yeah, surface. Yeah.
And now this
and then
is it extrude?
Yeah, extrude surface. Extrudes SRF, I think.
And now we can go 45.
Yeah.
Okay, and now we. And actually, this old bounding box, we can delete it and make an intersection between these two.
Exactly.
Intersect, or
Boolean intersect.
Boolean always.
Yeah, it's important because the split commands and the intersect commands, they are dealing with surfaces and will leave open, what you call it? Yeah, open borders. But the thing about Boolean is that if the prerequisites are met, then everything will be solids. So if you're using solids with Boolean operations, then it will be solids. All right. Yeah, and as you see, this is only by adjusting the height, it's got another feeling to it, or another...
it is.
Yeah, but it's also because now we have maximized the height of the material stock that we will be using tomorrow, and we can see that it leaves it's not by a far margin a very what do you call it, with the river, one would really have to like rethink about what height of material stock to use, or what scale to use, or perhaps both. But one thing we want to check here is do we have? Yeah, I think we have, because yes, that is one thing that I actually have like instructed the wrong way, because the lowest point that milling, that should be 3 millimeters above the lowest point of the material stock, the surface of the machine bed. And now I said, and I encourage you to like make a bounding box which was 45 millimeters down. But we actually need those 3 millimeters. We need those 3 millimeters in the bottom.
Okay.
Yes, so one thing we can easily do it now, since we have a planar surface in the bottom, we can simply extrude those 3 millimeters, or here is 3 meters.
Yeah.
But that was one thing that I instructed the wrong way, because when doing the Boolean operation and when creating the model, it should be like the model should be representing as closely as possible the actual model, and the model will not be sitting on 3 millimeters of air. It will be sitting on 3 millimeters of extra margin, so as to avoid cutting through.
So in a sense, if I want to take my piece of wood and do the model as it is now, I mean, as it is now, I would have to add 3 millimeters. What we're going to do.
Yeah.
But I could also say I want to cut it. I want it also to have the full cut outside, and then I would use the 3 millimeter like this. How was it called? Spoiler board.
Yes.
Like if I use a spoiler board, I do not have to extrude it.
Yes and no, because the 3 millimeter. But yeah, you are correct. Yes, it's an unconditional yes.
Okay, just to understand.
Yeah, but because the 3 millimeters are there, because if we say that this is MDF, even though it's not, if we say that this is MDF and it's positioned above the vacuum inlet, and the vacuum inlet is sucking at maximum suction, then we want to make sure that the lowest point of milling still leaves 3 millimeters of the MDF, so that it does not break from the suction. One part would destroy the model, and in another release the suction and perhaps destroy the machine. And the third would be to harm the vacuum, because there would be like MDF in the suction. In the vacuum inlets. So then it's very important with those 3 millimeters. But like you said, if you are cutting all the way through, if you have made sure that the vacuum sealing strips are both on the like inside of the contour toolpath and on the outside, so as to make sure that when it actually cuts through, that's the material that is outside of the model but still is part of the material stock, that it doesn't like flow away, fly away in any direction. So you've understood it perfectly clear.
Okay. So let's extrude this. Extrude surface. And 3 millimeters, so which are 3 meters.
Yeah.
Okay.
And it's still it's still a closed solid.
Yeah.
Perfect. All right, because now if you select this and make a bounding box, just to make me perfectly certain that it's correct, this should be then it's 48 millimeters, and that was the height of the material. Yeah. Perfect. Then everything is matching up. But let's not talk about culinarities. If you share your screen again, then we were in Rhino, and we were at the stage where like everything was prepared. We should just position it correctly, and so as we see here, I'll activate annotation mode again. Yeah, it's 48 meters, which 1 to 1000 is 48 millimeters, and that is perfect. That is what we have.
The one thing I realized though was that it is it's probably good mentioning, is that the piece of wood is 16. I mean, actually, I have two different ones, and the one I showed previously, it's not 23 centimeters large.
Oh, okay, yeah. So
I didn't thought that this is also something. It's 16 and a half.
I made the mistake of neglecting that. Of course, it's not only the height; it's also the width and the length.
Yeah.
But like you decide, because we can make a toolpath where it cuts into air. Like it's no problem for me, but then again, it's better if we prepare a tool, since we're testing things. I mean. But since we're at this stage, we can still, of course, reduce the bounding box to a width of the actual material stock that we're using. So
I'm just checking what are the most interesting, or like where can we cut off the most. How was it again? The function extract.
Extract surface.
Extract surface. Not this one, but this one.
Yeah, I think you can, if you hold control, and you can.
Then extrude surface. And then now we said 6. If I have 16 and a half, so it's 60.
Oh, is it so small?
No. It's I'm just. It must be like, yeah, exactly.
Yeah, okay, yeah. Yeah, I was really worried when when it was so small. But like this seems that we can still make something. We can still include a church there.
So we have here the church, we have here some parts.
Yeah.
Which I think in the end is fine as well.
Okay, so we can either hide or delete the original bounding box. Yeah, that one. And then we can Boolean intersection with the new one. Oj, vad hände där?
Boolean intersection.
Perfect. Yeah, and usually it is like when all the prerequisites are met, it's usually like no problem to continue Boolean operations. But so it was good. This was unproblematic. Should we test with because this was 1 meter down in a 1 to 1000 scale, so 1 millimeter. Should we test with like you can make like a phony road, like if you make one curve and
just like any shape or
offset. Yeah, you can make any shape.
Yeah, I can do this. Or I can also just do a square.
Yeah,
or
a square. Yeah.
Like this, and then maybe a bit longer. I think we can just have one here and then copy one here. And then.
Oh, sorry. I think that one had the edit points on, so.
Yeah, so it should be good. And now we said we have to project those to the ground. Just project or projection?
I think it was project.
Yeah. And now we have them twice because we have on top and on the bottom.
We can fix that by if you undo that command.
Control Z or
Control Z, exactly. We can undo that, and then we can actually extract the surface, and then we can extract that. And then we'll rejoin afterwards. Perfect. And now we can project again. Great.
Nice.
Were they closed in the end, or were they? I didn't see. If you
these were closed,
but
and closed.
The one that got projected, they are not closed.
Open. Yeah.
I'm just wondering if that's a problem for the. No, perhaps it's not, because now we're doing. Now we're selecting this surface that is separate or individual, or what you call it, and then we split with those. And since that has a border, it should not be a problem. It should be.
Yeah,
exactly.
It works.
And we can do the same for that one as well.
Yeah.
Okay, so then I must think now, because now we're on the edge here. If it's any problem doing this, perhaps it is, perhaps not.
Like of the edge here.
Yeah, we'll see. I think that since the edge, since the face of the edge is planar due to the nature of the bounding box, I think that it's okay to extract that and delete that, and then to make a cap in the end. Because now we will I guess that since this is extruded or like displaced 1 millimeter down, then 2 millimeters and 3 millimeters, or and then those will since it's like a separate surface, they will be there will be a non-manifold edge there, or a non-manifold face. They will have like 2 coplanar faces where the interior and the exterior is not evident. But that is not a problem, because we will delete this big one here. We will extract that and delete that, and then we will make a cap of the rest. And that will, since it's a planar face there, so it's all good.
So -2, -3,
and then we can take that and dupe border,
and then
extrude curve, and then precisely 2. Great, and we can delete, or that curve, it could be left like it is, or it could be deleted. It can be easily recreated by just duplicating boarding again. So for this one,
curve, that was a 3. And now I can I can say I take only the curves.
And delete those.
Oh man, you're kidding me. And then, as we said, extract, I deselect extract
surface, exactly. And that one, because that one is now a problem, but will not be when we cap it again. And, and you can make the same thing for those two. Let's see here. Perfect. And then join everything else. So select everything and Control J to join, and then cap it, and it should be. Yep. Good.
Nice.
It's a closed polysurface.
It's crazy how quick. I mean, once you know what to do and how to do, how quick things can be.
I'm wondering one thing. I'm looking at this thing here. What is that? It's not comforting, but what is it? Because I think but it's okay. Like it's looked really weird. But it's still a closed, solid manifold polysurface. So even though like that is not to be like it's not like the optimal input for Fusion 360, But as long as we see in Fusion 360 when we simulate that it's not a problem, then it's not a problem.
Okay. Okay.
But if because I would guess that Fusion 360 knows its own limitations in regards to 2.5D milling, that it can't mill out this pocket here as long as there's a solid material here, or like the model is solid there. But that is one thing, just to like, that's an area of interest that we can check in Fusion 360 what it does with.
Sounds good. Yeah.
All right, and yeah, with the risk of like turning or like sounding repetitious, but can we make a bounding box of this and make sure that it's 48
of course
millimeters, and then that all dimensions are possible to mill with the material that we have? So 235, 165, and 48.
Yeah,
that works.
Nice.
Okay.
Actually, it's smart to use a bounding box. I would have taken my line tool and gone underneath to go and check.
Yeah,
I didn't know that it shows you the measurements on top.
I have like thumbs in the middle of the hands, so I put greater like trust in the command which does it automatically than my own hands doing that.
That's true.
Yeah. All right, because then it's a very important thing to like be very conscious about, and that's the orientation of the model. Because right now, as we can see here with the gizmo here, it's got its long edge or long dimension or long axis along the x-axis, and as a matter of fact, the long axis, but on with the CNC router, the machine bed, the long axis there is the x-axis. That's the like 2.4 meter one, and the short axis is the y-axis. Like speaking in 2D, and then of course the z-axis is the z-axis. But that's like no one is confused about which one is the z-axis. But
that's true.
The x and y is important. So Rhino, it's really good because Rhino is let's see here, so I state this correctly, like all these coordinate systems in all these programs, they are Cartesian, they are X, Y, and Z, and that's perhaps what Descartes, like what he insisted on. But these all softwares, they have different approaches to how to interpret these axes, or how to orient these to each other. So Rhino is right-handed, which means that if you put your right hand like this, and I always get a little nervous when demonstrating it because I get it wrong, but that means that your thumb is the z-axis, your index finger, I think it's called, the x-axis, and the y-axis is pointing to the left of the x-axis. So these are like the y-axis is pointing to the left of the x-axis. These are like the positive orientations of the world space, or of the coordinates which Rhino uses. And Fusion 360 is really good about like if you export and import a Rhino file or a Rhino model, then it will take into account these the orientation of these axes. You will have to like visually make sure that it's correct, of course. But like I would assume, since it has done so before, that when it imports a model from Rhino, it automatically makes sure that it's right-handed. Like for instance, and why this is important is because the machine is right-handed as well. But it is, if one wants to complicate this, the Z in the machine is the opposite way down, or it begins at 0. Then it goes, but one has to make sure that the X and Y is correct. So here in Rhino, we will make sure that we position the if we're speaking like in the cardinal directions, the southwest corner of the bounding box in the Rhino origin, so that it points, or like that it extends towards the X positive and the Y positive.
Yeah.
Because then when we export it and when we import it into Fusion 360, it gets it is positioned in the correct way, as one also designates the home, the origin point during operation of the machining.
Yeah. Okay. So in this case, I can take it and move it now to the center point.
You can press 0. If you press 0 now, it will place it and enter.
Oh.
And it's, then you know it's like dead set. That perfect position.
Should I look also on top for the orientation that it's, or
yeah,
no,
you
it's, but it's fine.
The gizmo here you can see, and it's the same here. Like it follows in the 3D perspective viewport. It follows where you look, and you know that it's correct if it's aligned there. So like looking at this and knowing that the wooden board that you have chosen, it's got a certain width that was 165, but then I guess it was longer than 220.
Yes, we are like at 49.
Yeah, but then it's good
centimeters,
that we will, if you zoom out on the top viewport a little, then it's important that we, like with the CNC router tomorrow or CNC machine tomorrow, that we position the wooden material like it's not perfectly aligned now. It looks like, but like that.
To have the excess on this side.
Yeah, so the x-axis extends along the long edge of the wood, and then we will set the home, the soft origin or the soft home of the toolpath, which we will set in that corner, and then we will set in the perspective here, we will set the Z origin at this surface. And thus it will, like, even though we set them separately, it will know that the origin point is this point of the material stock.
But could you hypothetically, since the wood that I have fits in both direction on the table, could I also say, I mean, just like for the fun to switch it and say we look at the same model in this way here?
Yes, and it's perfectly valid. Like there is no correct way of orientating it in terms of like artistic vision. This does not like.
There's no influence on how
it's important to be aware of that. What you decide now will be what must be positioned later on. Because otherwise, like a more like fitting example for this was that students from the Maritime Robotics Lab, they had assembled like 5 or 6 sheets of MDF, like 24 millimeter each. So it was like material cost of up towards like 300 euros. And then it's it was proven like to be you have to be very careful about like before I will show you tomorrow as well, but like before you actually execute a toolpath, that you see that the orientation of the toolpath is correct, because then like we could see beforehand and abort, like, or not abort, but like we could like totally avoid running that toolpath and then redoing it so that the orientation were correct, because otherwise it would begin to mill and like excavate the material, but in 90 degrees counterclockwise direction, and that would like ruin the 300 euro worth of material. So it's better to like measure twice, cut once, to also check twice and mill once.
Better safe than sorry.
Better safe than sorry. one thing to take into account when milling hardwood, which we will, is that the direction of the fibers, they are, of course, like if we would have a square piece and a square based toolpath, then the results would be, for the surface at least, would be a little different, of course, like if it was rotated with the fibers along one direction or the fibers along another direction.
Because it's wood and not MDF.
Because it's wood, exactly. But that does only apply to like the surface that you want to have. What do you want? Which direction do you want to get accentuated or not? Like perhaps in the final model with the river, and if you're using hardwood, then perhaps like to have the fibers along the, or like it might be impossible because the river is flowing across or I don't know if it was the length of the like that's one thing to consider, but it's not it's not essential at this time, but it's good.
I understand.
But now, like, let's make a mental note that this model that we are milling, this test model, it is oriented so that its longer edge or longer axis is along the x-axis. And that we will need to put the material stock so that the long part of it is along the x-axis as well on the machine. Great. We can select this. And just one thing, you made sure that it was this lower corner that was, I can see that, and I do remember it. So we are actually like completely ready for exporting, except that the bounding box should not be exported. The bounding box has been of great help, but it can be hidden or deleted. So this is what I said before, that the model that we export and import to Fusion 360 should be as closely resembling to the end result as we want. And then, of course, there will be limitations with the diameter of the bit and what it will look like. But this will be really interesting, what we can achieve now during simulation and authoring of the toolpath. You can select this and just for the last time check that it's a closed solid poly surface. Perfect. And then we can export this. And then it's important that we export this as a Rhino 5 model. Due to compatibility with Fusion 360, because one has to take into account that they are like competing businesses and they are not that interested in like maintaining the highest degree of interoperability. But Rhino 5 model is tested and true to work perfectly with Fusion 360.
Okay, so let's go here and let's make this a version 4. Or all right, this is really fun because now like the and I really want to stress this, but in a non-stressing way. But like I really want to put emphasis on this, that with this Fusion 360 workflow, most of the actual work is done before Fusion 360. Okay.
Like this is like the most important part about making sure that you get a possibility of nice end results. Then the toolpath authoring that we will be doing now, that's more of a matter of like picking the right parameter values and like testing with simulation and what kind of resemblance to the original model do you get. But you will never get better results than what you put in at this moment, at this stage. So this is really important. And you have done it really, really good. So it's great. I'm excited now to we can Fusion 360 will be using during the computation of the toolpath quite some processing power. So we can not shut down, but we can exit Rhino.
Okay.
Free the memory, and I don't think that the processor has any problem with like Rhino in the background, but we can just make sure that it wants to save because you saved as a Rhino 5 model. And now this is really fun. Like now it begins. and Carl, like, say if the tempo is too slow or too fast, and like I know the most encouraging thing for me in this context is that you're eager to learn, and that's like really fun, because
Yeah.
this could be done also, like okay, like I give you some assistance with modeling this Rhino, and then you give the model to me and I give you the toolpath. But this is more interesting to me. All right, so when you're in Fusion 360, you're greeted with this blank space, and it's quite it can be frustrating if you try to close this. Like I'm sometimes I'm a little annoyed by like like having an open tab, and if you press it, it will open a new. So
Okay.
you will not be getting rid of. You must have an active document. But then let's see. I think it is this grid here. You can open a side pane, exactly, and this, and here, like you see your team here, Blue Fire team. And here you can see all your projects, and it might be a little unintuitive, but like you have I call them projects, but they are sorted in what I would call folders, but those folders are what Fusion 360 calls projects, and in those projects you have like design documents. But I guess that it's like dependent on how you work with it. But so you can click here to make a new project, and that is in essence, like for me, it's making a new folder. Perfect. And I would like a general tip is, especially when making toolpaths, is to exclude like the o, ö, exclude the special characters.
Yeah.
You can be like more or less orthodox about it. Myself, I like no spaces and no special characters. But like when it comes to the toolpath file, I would severely like advise against special characters like Södertälje, like
yeah, true.
But like for a project file, I guess that it's okay. But since I got the opportunity to say it, because the CNC machine, it's a multicam, an American machine, and the G code file that we will be outputting, it's a very like low level. It's like the machine will read it line per line, and I guess that if it does not allow for special characters in its file name, then I guess that it simply won't read it. But that could be a problem as well. Yeah, I would suggest the toolpath that we will be outputting, at least. That it's very like yeah, it could be like underscores instead of spaces if you want, and like it could be, but I won't say that it won't work with or something, but I would advise against it.
Just to make sure,
yeah. And when you created the project, you can double click on it, and now like when you're in the project, you're in the actual like folder where you can have individual document files, and now if you press upload. And that is one thing to note, that Fusion 360 is completely cloud-based. So even though the last few projects are like kept offline, or that is one thing to note, that they are kept, they are locally stored, but everything is synced to the Autodesk cloud storage. And Autodesk takes the liberty of like deciding a little, if you haven't used a project for long, that they can simply delete the local files, the local project files, but they are still retained in the cloud. But it's like like it or not, but it's better if you are connected to the internet when doing this, because every revision, every change that you made, it's got this online versioning, so that I would not suggest like bringing the bringing the laptop to a remote cottage and work on.
Okay.
But it's good to be up. It's good to be connected to the internet.
Yeah.
And now here we can select files, and then we simply select the exported Rhino file, the Rhino 5 file.
That's this one.
Yeah, it was in the other. I also get a little confused with the date modifier. Sometimes it gets in like the ascending order or descending order, and like, oh no, it's not here, but it was simply in the bottom instead. And then I guess that it's you can click upload. And then this, depending on the complexity of the model, it might take a very short time or longer. And there's also one opportunity to say that this is one of the instances where the educational license is permitting, while the hobby personal license is very restrictive, because that's also like a very artificial limitation. But with the hobby license, you can't use Rhino 5 models. You must, which is of course possible as well. You must export it into an IGS model and then import it as such. And it's like it's both NURBS models, but the IGS file has separated surfaces, but they will still be but it's good with the educational license. And when it's complete, you just press close, and then if you double click here, you can open it. And if everything is correct, then it should be positioned in the way we expect. And you can see here that the x-axis is the long, and everything looks good. It's positioned at the origin point. It looks very good. All right, and now Fusion 360 has these so-called workspaces, I think. So now we're in the design workspace, but we will change that to manufacture. And then things are a little more prepared for what we intend to do with it, because Fusion 360 is also a competent modeling program. But I would not exchange it for Rhino any day. All right, the first thing that we will need to verify, having already verified the orientation of the model, is that the units are millimeter. And that is correct. And that is one thing that I wonder. I don't have a clear memory of us scaling it down.
But what could be interesting to check is it might be millimeters, but we don't know how many millimeters. It might not be scaled yet.
Yeah, I think that
inspect.
Yeah, and it's quite it's a different mouse layout, but you'll get used to it. And
yeah,
so you see that this is not
not scaled.
or order of magnitude of what's that say? Is it plus 0.9 or plus
0.5?
Plus 0.5. So it's this is I'm not mathematics, but
no, but it's
but we that's really good. That we should always export it in like this wasn't scaled to 1:1, but this was scaled 1:1 like in real world space. We could scale it 1:1 so that it is in
the model
that we intend to fabricate. And I find it nice that it's automatically converted to millimeter, still retain the actual distance of far too wide. But thus we know that we won't be needing to change the. We can simply scale down. We don't need to change the unit in Rhino. But then that raises the question, of course, that if we scale down with a factor of 1,000, that is lower or as equally low as I think that Rhino's default tolerance is. So perhaps if we go, I know that we quit Rhino, but we should start it again so that we can fix this, because this is something that we of course could.
So what you're saying is it's better to fix this in Rhino than doing it now because of the tolerance.
Definitely. I don't know if I don't know if I guess that the outcome would, but I would make sure that the model in Rhino that we export is as close to the actual model that we're going to fabricate as possible, because you know, scaling by such a large factor, I think it says here, does it say anywhere here what we have tolerance? If you, I think if you double click the meters down here, did you scale or not? Because I think we should do this before.
I didn't scale yet.
Yeah, we could. You see where it says meters. If you, I think if you double click that, or if you right click on it and
Right.
use settings, it says here that the tolerance is, yeah, it's 1,000 of a meter, which means that if we have something that is less than a meter and we scale down that by a factor of 0.001, then we are below tolerance. And being below tolerance means that Rhino takes the liberty to interpret the geometry like in the way it finds fitting, given the tolerance. I think that this is mostly critical when doing all commands. Like if you do a Boolean difference and Boolean union, the absolute tolerance will be what decides if the if two like closely coplanar surfaces actually are interpreted as that or not. But since we have that absolute tolerance of 0.001, I would first change it to the model units to millimeters. And then we would have, and if you press OK.
Now we have
and then we have the opportunity to scale the model by 1,000, and then we can simply press no. Because now, if we press this again and press and type bounding box, it should say, since this has been reinterpreted as a millimeter units, but without scaling it, then it should be like it should be in the same way as like scaling it up to 1,000 and scaling it down. Yeah, great. Because then we can now we can export it again. Sorry for like not.
Shouldn't we scale it first?
No, because you know that we got the opportunity to, or if you either go up a little. Sorry, wait. If you press this button to go up a little in the list here, it says, yeah, these are the correct numbers that we're expecting. 165 millimeters, 48 millimeters.
Is it not 48,000 millimeters?
I would guess not, because the point here, I think it's a decimal point. One can of course make this perfectly clear in some smart way, which I can't figure out now. But like if you
no, it's you're right. Okay.
Is it so?
I mean,
yeah, because I would say that it's also it fits with the presumption that the tolerance is 0.001 units, and then I will, but I'm not.
No. But I think in the end, because when the box came up, I clicked it the way you know, but so I didn't remember if it should suggested to scale it like dividing by 1,000 or multiplying by 1,000.
Okay, yeah, but
probably it was multiplying by 1,000.
Yeah, if we would have done that, then it would have been scaled by a factor of 1,000, and then we would scale it down by a factor of 1,000
again.
1,000th.
But in a sense, if I would have accepted what in the box which popped up, we would have stayed in the 1-to-1 real scale dimensions.
Yeah, that would have been the, like, if it would have been another scenario where you perhaps like initially modeled in a millimeter scale, and then you understood that, oh, this is an urban scale, and then you want to change to centimeters or to meters, then you would accept that rescale so as to keep it 1-to-1.
So I proceed deleting the bounding box and exporting the model as we did before.
Great. I was that was the thing. I was too excited about like moving to Fusion 360 so that I forgot to make sure that. Yeah, and I don't know why that pop-up came out now but not before, or did it pop up?
No, it did not before.
No, I don't know why there was the difference in the pop-up appearance or not, but it's totally fine.
Now we go back to Fusion.
I guess that there are some metadata, something beyond the actual 3D model that Rhino 6 keeps track of, which Rhino 5 did not. All right, so now we can do it again here. And I always like when there's like this sort of one could of course like import it here and but I would prefer that to if you close this and it will open the untitled document, but then you can delete this. So right clicking a little to the left and then delete.
And then upload again.
Yeah. And then it's on the bottom.
Nice, yeah. Upload.
I must say, like in this short post, that I'm really happy. Like this is the first time I'm doing this remote consultation, but I'm really happy because I see what you see, and the resolution is. It's not like I have to be this close, or like I feel like I can follow perfectly well. It's not. It's not a hindrance that we're doing this on your computer, so that you're actually learning by muscle memory and the like. That's,
yeah.
All right, and then double click to open, or right click and open.
Like I have to say, like I don't think I ever did. I mean, consultation so interactively like this before, but I think it's really I have a really good feeling from it. I think it's nice.
So now we're again in the design workspace, so we can move into the manufacture. I don't know what that is. Yeah, it's simply the manufacturing without the manual work. All right, and here we double check that it's in a millimeter scale. We check that the X is along the long as we expect. And now we also see with the grid here that you see that the grid is like I don't know really how it was before, but I didn't see this before. I think it was like really oversized, so it did not show those things. All right, the first thing that we do is that we add a so-called setup, and the setup is simply a representation of the material stock. When doing a setup or when configuring a setup, you configure the material stock, and this is one thing. It will be more obvious when we actually make a setup, but the setup is not necessarily one-to-one with your actual material, but the setup will be what Fusion 360 is actively calculating to mill or to excavate layer per layer. So you can have, like we will have, a longer wooden piece or like wooden plank than the bounding box of the model that we are milling. And Fusion 360 will only take into account the setup or the material stock that we are assigning now.
Yeah.
But one has to like be aware that if your actual material extends further, that you like take this into consideration, and when you look at the toolpath that we will be authoring as well, that you do not allow it to make any unsolicited movement outside of the material stock if you know that there is material there. One better example is that if you make a roughing toolpath, that is one with a larger diameter bit, just to remove as much material as you can, and then to make a finishing toolpath with a smaller diameter bits, then it's very important if you have a larger material than your setup, than your material stock, that you make sure that the finishing pass, or not the finishing pass, but the finishing toolpath does not extend outside of the initial roughing toolpath.
Yeah.
The roughing toolpath will only be calculated with regards to the stock size that you're setting up. But you have to be aware if you have more material. That's yeah.
But especially if you're having two different paths.
Yeah, especially then, because the first,
like in a sense, if you're doing the cup, and then you have like the big one who takes out the big part, and then you have the small one. I mean, the cup is a bit stupid, but if you would have an opening, or like that, the small one doesn't hit.
Yeah, I can show like with a little drawing here. Let's pretend that the roughing toolpath goes along the edges here to remove as much material, and then everything inside here as well. But like this was a really like a rough sketch. But then pretend this is another color, because it's representing another toolpath now. If the finishing toolpath that follows, if it enters the material stock like this, then Fusion 360 does not know that this actually is a continuance of the
material.
Yeah. But then
so technically it would like hit the material.
It would hit the material,
and then might break the bit.
Exactly. It's in like a best case scenario, it would break the bit. In a worst case scenario, there will be damage to the spindle, and we will avoid that. But I will show you how to make sure that you can make a roughing toolpath and make sure that that is correct, and then you can set a boundary to any succeeding, successor, to any successive toolpath, that it does not extend beyond that.
Okay.
So I will show you that. All right, but we'll begin by setting up the setup. So doing that, you right click on the setups there.
All right, sorry.
Yeah, and then you press new setup. And now you see a visualization of the of Fusion 360's presumed stock material stock. But we will make sure that it is perfectly co-aligned to our expectations, or to our like planned milling. And for this, it's like when doing both the setup and the toolpath, this is the important thing. And like I previously said, Fusion 360 is amazing in terms of user experience and user interface, because anything that you hover long enough over will show you like an image of what it represents, and or it's fantastic in that way. So you can easily like we can do this now, but you can also like just acquaint yourself to the user interface, and like anything that intrigues you, you can just hover over and you see. Let's see now. So and you tell me if like there's any parameter you want to know more about, and I'll see if I know anything about it. But for this and for any toolpath which will be milled with the machine at school, you don't need to select a certain machine. That is only if you have a pre-configured machine parameter or machine setup in Fusion 360, which you don't need. And operation type, I will say if you like don't know what I'm pointing at, because I think that these lines, it makes it hard for me to see, and it takes some time. So, but say if you don't know, I will just go from the top and to the bottom, and then but if it's like any confusion, just say the word. An operation type is milling. And the orientation, here we see that it's automatically set to the model orientation, so the imported model. And the origin is a stock box point. And as you see with the blue like selection, you are free to choose any of these points to the left.
So I could go and take the one, our point here. I know we want the one on the
exactly. You already know this. So
Okay.
I can like explain a little, but you already have the right choice, or the right selection here.
Yeah.
Then we will pick that one because it's the stock point, that is the top of the stock, but also immediately above, vertically above the origin points. But that is not what I stated now is not correct at this time, because Fusion 360 by default it offsets the stock, the setup here. It offsets the stock by 1 millimeter beyond the bounding box.
Offsets in what direction?
In both like X and Y direction, 1 millimeter from each face. But this is something we will revert, or we will make sure that it is 0 offset. One can, of course, if one has taken that into account when choosing the material and when and when designing the model. One can, like if we are cutting all the way through, then it would be important to have more stock on the side than the actual model to be excavated holds. But now, since we won't be cutting all the way through, we will instead revert this offset, or like totally eliminate it. But it's good to select that one that is above the origin point and on the stock top surface. So perfect origin selection there. So we can now go to the second tab here. It's the yellow box there, and I think it's there that we will actually set up the offsets.
Okay.
So here we can keep the mode to relative size, and we can keep the offset mode to add stock. But these are the parameters that should be, or parameters. These are the dimensions that should be matching up to our intended stock and our material in this case. Or at least for the Y dimension and the Z dimension. The X dimension will extend farther than we will actually be cutting.
So then we have to lower it to 0 in order to get to the one.
Exactly. And like you see, it's not only by default adds 1 millimeter to each side, but it also adds 1 millimeter to the top. And this was like recommended by me, that we actually have 1 millimeter stock top. But like we discussed, we will try this out with like this one should be like point blank, or what you say, and this one should be 1 millimeter under. So it will simulate like both options. All right, and then we can see that we have 165 millimeters and 48 millimeters, and that is precisely what we expect, and that's really good. And one thing to note already here is that this, of course, will mean that the plank, it will like leave, it will it will look like this, or like it will look like this. Yeah, you understand but what I want to make sure about is that already at this stage, to be aware that no toolpath should, or like the roughing toolpath can, and it's okay if it does, and I think it's good if it does, to as an example, make sure that this part of the church gets excavated. But yeah, one has to be aware that the material continues there.
Yeah, that no toolpath will kind of like, I don't know, like halfway through cross here.
Yeah, exactly. So that, and if the roughing toolpath does it initially, then it's something just to be aware of, that okay, like this material will get cut outside of the setup, which is totally fine if it's expected or like if you are aware of it.
But if we say, because I mean, if let's imagine we put our piece of wood and there's a toolpath would like go outside of this bounding box, because the thing is, as if the time of the spread, I mean, shouldn't we avoid by all costs it from go outside of it, because it, like, in order not to damage it?
To damage what precisely?
The drill or the parts of the machine.
That depends on what kind of movement it is actually doing, because if it is
if it's a drilling movement, it's fine, but if it's a quick moving movement, then no.
There should be no like rapid movements. But then again, the spindle or like the tool will retract during these rapid moves, and it will retract 5 millimeters above this origin point.
Okay.
The stock top. So it won't be. We will not see a scenario where it will like take a shortcut like this and into the material. Deep into it will always retract to the safe height, 5 millimeters above the. But then of course we have to be absolutely certain that that the material over here
is not
so that is not like 10 millimeters thicker there for any reason.
So maybe if you, let's say, imagine you have you want to engrave something in a door. Like, I don't know, and then you would have to make sure that to take into consideration that the safe height is maybe not 5 millimeter above, but maybe 50 millimeter above.
Yeah, exactly. If the door has like these panels where the panel is lower than the rest of the door, then
Okay.
I was like intrigued by the example, because I wondered like how would you fixate the door with the vacuum suction? But to get the point through, that was an excellent example. But I would not like I would not recommend that material stock for like the first three.
No. I don't know why I didn't even think about the suction. It was more just about that you can maybe...
but the different heights. Then it would be really important to make sure that and we will set that here, and I have a recommendation of 5 millimeter as a minimum, and if your stock material is sufficiently flat, then that's perfectly enough.
I don't know, just maybe if I'm asking too much,
I encourage it. The more you ask, the more you and I learn both. So
because I'm thinking, like, hypothetically, if now imagine you have a customer who has this door which is already existing, and for some reasons he really wants to have something cut into it, even though the door, let's say the surface of the door might not work for the suction, could you build a support, something that you have under the door, and then you might attach the door to the support, and then the support gets sucked?
We have a current, yes, we have a current project that actually it's like the same problem, but different material, not a door. But,
I don't know why I came up with the story.
An uneven surface of I don't know, a tree trunk. Surface of a tree trunk, and this tree trunk could not be, since it's so uneven on the bottom, could not be securely suctioned on the vacuum like with sealing strips. It's impossible. But then like you said, like precisely you said, they have attached a pretty first they tried MDF, but like I said before, MDF is like a porous permissible material which lets the air flow through. So it's like a form plywood with some surface sheet, so that it's not air permissible. And then with the screwdrivers and the screws attach that to the tree trunk.
Okay. Yeah.
Yeah. So that's one way to do it. If you could, like for the door, cover up the drilling holes afterwards, then I would suggest to do that as well.
Okay.
All right. Yeah, and we have now made sure that the stock dimensions is according to expectation.
Mm-hmm.
And then the next tab is we will not be doing anything there or doing any adjustments, but we can still, like if you want, we can like enter that third tab, because that's only sets like default values when we save the G-code file. But we can change, we can like when we actually output the G-code file, we can specify at that stage instead. All right, and one thing that is a little quirky about Fusion 360 is that with all of these, with both the setup and with the toolpath, you get these what do you call them? But like nothing gets saved before you press OK, and if you press cancel, then like so you have to press, and as such you can just double check that every value on all tabs are correct, and then press OK.
Okay.
And now you see that now we have a setup one there.
Oh, so you can have different setups.
Yeah, you could have different setups, and like the machine at school, it has the not opportunity, but it has the possibility of like setting many different homes, and like but for simplicity's sake, we will be using one setup and one like chained link of series of toolpaths with a possibility of different tools. So there's an automatic tool change implemented software as well. All right, so now we have the setup, and it's perfect because now with that setup, and you see that it's selected in blue here. Let's see. Yeah, but it's selected in blue there. You can add like any toolpath. I will just make sure that, but not the drilling toolpath is not recommended, since that like the router bits that we use in school, they are made for ramping in. They are not made for drilling vertically. But they are made for like ramping in, like you would on a ramp, like either a helical spiral entering or ramping in a degree in an angle. But like any 2D toolpath or any so-called 3D toolpath, well, but with like these layers, is perfectly fine. And we'll be using the 3D adaptive toolpath. It's why it's recommended by me. It's because it takes into account two things and like prioritize this. It's tool like actual router bit endurance, because while the machine should last like half an eternity if used well, all router bits will, like due to the engagement with the material at several thousands of RPM, they have a lifetime. But if used correctly, with appropriate feed rates and appropriate spindle speeds and appropriate ship load per tooth, so-called, and with toolpaths that take durability into account, and now with the risk of like listing too many factors here, but also whether you drill but whether you mill conventionally or so-called climbing, it's simply because the spindle is spinning, and then when it spins, it has, I know that like here in the hallway it's not as easy for me to show, but it's spinning and it has teeth. It can have one tooth, or it can have like two teeth, or it can have 3 or 4. but they're all spinning in the same direction, and that makes it possible for the router to engage in the material either by climbing, like you see. It's like I understand the limitations of this demonstration, but either by climbing like this, it makes this like it climbs into the material like that. You have to like think that I'm there. Or it engages in the other way, which makes it like this. It's still making the same sort of it's still making the same rotation, but it's more like I say it's more rubbing into the material. But and it can prove that conventional milling can give a nicer surface for some materials and for some circumstances, but in all circumstances, they since they are rubbing so much against the material as opposed to climbing, where it takes more like
actively taking the material off, like almost like a saw. Instead of filing it, it's less this contact, but more.
Yeah, and it's with a climbing toolpath for climb milling, the durability is more than twice than with conventional milling. So like as at least partial responsibility for the durability of the work of the CNC workshop, then I recommend climb milling. But I don't know how we got into this. Like we haven't still yet added a toolpath, but I think that it was.
But then, quick question: so if the climbing is the one which is more durable, but the rubbing gives a nicer finish
for some circumstances, yes.
Because can you? I mean, maybe we just have to go ahead, and my answers will be cleared later. But could you have one toolpath which does the climbing and take the big material away, and then you have a second one who does the fine?
That is actually like recommended if you want to like maximize the surface finish without sacrificing too much of the durability, to do precisely as you say. But I find that the differences between the surface finish is not that much. It depends more on the fibers, on the direction of the fibers and the direction of the toolpath than whether milling conventionally or climbing. And also router bits at school are so-called upcuts. They're flutes, like all router bits have teeth, and the teeth are like the entry points of the flutes, and each flute is like a sharp blade and with a channel between every flute. The channels are oriented in such a way that the flutes that takes away the material, also the channels between the flutes excavate, or it's like pushing the material up. And it's really good for the extraction of milled material. No matter what material you cut, it's really good that it gets like, instead of pushed down into the perhaps the channel you are contouring, it gets excavated. I guess it's good for the durability of the bit. It's good for the temperature, because you reduce the friction if you push down. There are downcut bits as well, and the perk about downcut bits are that they leave a nicer top finish, because if you think with plywood, it's more of a occurring thing where you have these like thin sheets, and with an upcut bit sometimes these thin layers, they get what do you call it, fuzzy, or like a little
it's like when you saw as well, like then if you saw some plywood, then you don't have a nice finish in the end.
Exactly. And then in those cases you could like theoretically use a downcut bit, but then that could mean that a lot of the milled material, which the dust extractor otherwise would have caught on the way up, that they get pushed down into the material, or like into the channel where you're. But like I think it's really good that we tomorrow test, because then you will see firsthand the results of what we are now experimenting with. Yeah, we can take the 3D adaptive. So under the 3D
here, adaptive.
The adaptive clearing, the 3D adaptive clearing. And now, precisely like with the setup, the toolpath does not get added to the project before actually pressing OK, which we will be doing after we have set all the parameters. Yes, and now we are come to like the really exciting parts, because now it's all about the tools. And speaking of the tools, I will show you how to import the tool library of the tools that we have available in school. So for this, like I said, if one would have like made a lot of, one would not have made a lot of adjustments to these parameters without selecting a tool. But like I said, it's like either you press OK and the toolpath gets calculated, or you press cancel and like, okay, if you did anything, then it gets discarded. But you can press cancel now. We haven't done anything because we will be importing the. You have acquainted yourself with the CNC, with the KTH CNC Google Drive. In that, so you can in Chrome open that. Yeah, perfect. In the Fusion 360. In the Fusion 360 subdirectory, there is another subdirectory called the tool library, I think. So the second from the top there, there is tool library, and the lowest one, or the one furthest down. If you download that, that's the Fusion 360 tool library.
Okay, should be downloaded.
All right, then we. I think it's here on the manage. There should be tool library, precisely. And then I think it's when you right-click local, or if that's not allowed, then if you right-click library. I think that you could right-click library. Was that not
right?
allowed?
Yeah. Sorry. Actually, also.
Oh, okay, yeah. Then you can import libraries, and then you just import the downloaded file. Perfect. Here you have all the tools available. So as you can see that all which has number 1, it's actually there. This one does not have one because it's decommissioned, because it was partially broken, and it's still in the library, so that we know that there has been such a router bit, so that if the need arises, we can order that again. But like if there is no what do you call it, not desire, but if there is no
special need for it, then
if there is no need for it, then it can stay decommissioned, or like this doesn't need to be replaced. But it's good that it's still there. All right, and you can, if you press this cogwheel button, you can choose what variables to show, and I would suggest to show the, if you go further down, I think that the description could be good as well. I think that there is some information for the description, like there. Oh, sorry, like this one.
Yeah. Sorry. Okay. Yeah.
No, it said nothing, so you can uncheck that. Sorry. Yeah. but some of these have information which is
okay,
like
so you
good.
can see
You can choose what you want. So the manage tool change is not important, but the number of flutes is important. Exactly, and the product ID is that's the parameter that we appropriated to have as like the index for what tool is what. Oh yeah. And going further down, and going further down, and going further down. No, I think that we have we have what is like. Yeah, we could hide the corner radius because corner radius we don't have any.
Sure.
But like this is nitpicking, or this is like really, yeah. But good, because then we see all the product IDs there, and that makes it easy to if you just for this now press close over down here.
I think yeah. Close.
Because now it's important. But if you go back to Google Chrome and check the same folder, there's this index of product ID. Yeah, this one. And you can double click on that, and then you see that for the indices that have been indexed, then you can see what they also look like, because only looking at the parameters might not be as clear as actually seeing okay, but it looks like this. It's so it could be good to identify which bit is which. Now we are ready to actually add a toolpath, because now we have this tool library that we can use to select a tool. So now we can press, I think that this is adaptive 3D, but otherwise it's shown in the lower one as well, but it's adaptive.
Yes, adaptive. No, okay, it's E2, not 2D.
I think that it just had this memory of previous, but yeah. So now the first thing we can do is select the tool. And then we will, then it's open as the same, and then you can go to the tool library KTH, and that's the tool library that we imported. And I usually sort this by diameter, and I wonder if diameter. Can you please with the cogwheel again, just to make sure that there is not. I just wonder. I'm too curious. Sorry, but if you press the cogwheel again and type in. Either shank, so S, and shaft diameter. Test that shaft. If you check that shaft diameter, shaft and shank is the same, because good. That's a really important variable as well, because the diameter, the cutting diameter, that's the actual diameter that will be like calculated as the milling operation. But as you can see here, there and there, as you can see here, the cutting diameter is less than the shaft diameter. If you click on any of these tools or router bits, then I think that it will show a preview to the right. Yeah, exactly. The shoulder length is actually this.
Okay.
Yeah, and the flute length. Let's see, if you select this the top one here. Yeah, okay, this was more evident here. Here you can see that the flutes extend 20 millimeters from the point of engagement. And then that's like the sharp flutes. But then there's a small section between the sharp flutes and the very dull shank or shaft, and that is the shoulder length here, I guess. But actually, no. Okay. The shoulder length is also from the end to there. It must be. If the flute length is 20 and the shoulder length is 27, so it should be that. But that is when you use a router bit that has a smaller cutting diameter than the shaft diameter.
Mhm.
And it's really important not to cut deeper than preferably the flute length, but at the maximum the shoulder length minus a couple of millimeters to make sure that the extraction is sufficient, that material actually can be extracted. Yeah, this was like not a parenthesis because this is important, but it was now we encountered this. All right, but now since we are like since we are intending to do this like a roughing toolpath initially.
But this is, I mean, yeah, it's actually not even that. I mean, it's quite. Imagine if you have if you need to do a longer flat thing, it means that it becomes the limitation. I mean, it's yeah. I'm aware that there are more limitations that I thought. Like you couldn't do I don't know. Imagine like the facade of a house which is just flat.
Exactly.
But 15 centimeters height, you couldn't do this.
No, exactly. As long as because if you press once more on the diameter here, and we go from the widest bit, I think it's 16 millimeters. If you go to the top, if you scroll to the top as well, yeah, it's 16 millimeters. You can see those are the overall length here, the total length of the bit or the tool. They are really tall, or really long. But this value should always be subtracted with 25 millimeters, which is the same amount you will have to insert the tool into the collet where the tool is inserted to. So for this you will have like 126 millimeters of possible cutting, since this has the same cutting diameter as the shaft diameter. But one can see here also that the flute length, it's only 30 millimeters of actually sharp flutes, and then the extraction goes from like the segment from 30 millimeter to 49 millimeter. But since the shank is the same diameter as the flute, it's not a problem, but one has to be aware that there can be like it could lead to temperature rising because of the rotation between the dull. It will rub, and for some materials and for some toolpaths, it's one has to. That's like there are a lot of reasons why one always has to supervise the operation, even though one has done it 1,000 times before. You always have to supervise it, because things can happen, and then like you have to press the emergency button if it's an emergency, and you have to pause it if you look at it and you see that it's not going to go perfectly well. So all right, but since we were making a clearing toolpath, I know that this product ID 25 I know is reliable. like all of these should be reliable. I just know that that the number 25 we have used, and that's also because it's a flat end mill. Like if you click on the flat, or if you click on this, you will see that this where it meets the material in the lower end is totally flat, and that has the upside, or the pro the advantage of being able to get rid of much of material, because everywhere it goes, it gets rid of laterally 16 millimeters of material. It's very much.
But then when you want to do the terrain, the finish, you don't want to use this one.
No, because then it will be.
Then it doesn't.
No, it would be because like some want and search for like a result with like very much stepping, and I think that it can be really nice as well. But if one would like to have like a more like a Rhino patch smooth surface, then it's much better to like use this as a roughing toolpath, just to use this tool with a roughing toolpath just to get rid of as much material as possible in the shortest amount of time, and then to invest a lot of time with a smaller diameter bit and just like progress like very delicately through the rest. But if you click on the highest one here, you can see that it's got the same diameter, but it's a ball end mill, and that means that it actually only reaches the material at maximum depth at one, like infinitely small, no, but at one point in the center point. And then with a radius of 8 millimeter, it does not. And by using a ball end mill, you will have in the milling result you will get a thing called scallops, or like these waves. So when done with a large diameter ball end mill, you will get excessive waves. They will be like, for this, it does not necessarily have to be like 8 millimeters of scallops or like 60 millimeters diameter, because there will be some overlap.
But so this could influence the textures somebody can want to have in the end.
Yeah, and these scallops, when they are excessive, like one also everyone has their taste, and perhaps like these scallops are what one really wants, and then it could, because like everything will be simulated, so you can try it with this one and simulate, and try another one and simulate. But often it is good practice because like there's a advantage and disadvantage. With a flat end mill, you get rid of lots of materials. For flat surfaces, it replicates the flatness perfectly. With ball end mills, you don't get rid of as much material, and there will always be these scallops, and depending on the diameter size, the scallops will be more or less visible. But due to the nature of the scallops, that they are thin in the top and flattening out, it's really easy to sand away. It's harder to make a step if one uses the flat end mill and gets this stepping. Then it's like it takes much more effort to sand away those those steps. Than to do the same with the scallops, because the scallops are like thin in there. All right, but I would suggest now, because I see now that this number 25 here, or index 25, it's the only flat end mill of 60 millimeters diameter. I would suggest that we use this as a roughing tool. And then it is important that when we select this, that we first select this. So now that we have selected this, due to the nature of it being a very large diameter, it will serve the purpose of roughing very nice, because it will get rid of much material in a short amount of time. We can select it. And because you can select it now, but you just take note here that there's a documents here. There's this document settings, or document section, and there's a local section. And now we're in the local section. We're selecting from the library, and when we press select, we will actually add it to the document. So, and I will show you that if you press select. Perfect. Now you see the end mill here, and you see that it's really large in comparison to the small model. But having done this now, I will show you for this as well. But even though it's not necessary, because all of these tools in the tool library that actually are there and are working have as a default tool number 1. And it's really important that the tool number that each tool that is used for any toolpath is assigned the correct number that they will be positioned in the tool holder. The main thing is that there are 6 tool holders that the machine has, and it has an automatic tool change software implemented in it, or a plugin.
Yeah.
And it will read in the G-code what tool number is used, and it will fetch that tool from the tool holder. But you as a human is the only one who has actual like consciousness about which tool is in the tool holder.
Yeah.
Worst case scenario, the tool number set here in Fusion 360 is wrong, and while it tries to fetch that tool holder, there's another tool there. Perhaps it's the worst I can't remember I can't figure out the worst scenario, which one is the worst, but like if certain tool is already attached to the spindle and it tries to leave it in a tool holder, which one has by mistake placed another tool in, those 2 tools will collide in the tool holder area, and which will certainly damage the spindle and perhaps the tools as well, but the spindle is like the most valuable part of the machine. So that is to be like another scenario is that you calibrate a certain tool which you think you have prepared for the toolpath, but then by mistake if you put the wrong tool number, then it can fetch another one which has not been calibrated and use that instead. And hopefully all of this is like you either press the emergency button if you like deem it's critical enough, or you press pause, or like but like if it's about to go to a tool holder which already has a tool in it, you press the emergency button definitely. But like I just want to tell you that it's really important that and you will get like a reminder, not like a pop-up, but you will see here all the toolpaths that you assign or that you author will have a tool number assigned to them. And if you know that you will be using 2 different tools, then you should make sure that like all different toolpaths for the different tools, that they have the correct number assigned to them. And of course this gets equal or like increasingly complex if you use more number of tools, but it's very common to use 2 tools, like 2 tools, like one for roughing and one for finishing. There's no point in using like one for roughing and one for like first layer of finishing and then another for the third layer of finishing, like if there is no conscious
special needs
for it, because otherwise you get rid of in the initial tool path, you get rid of as much material as possible, and in the second you define the surface. But if you're using it, it's very important to have those tool numbers correct, and that is why I want to show you how to handle that already here, even though it's set by default to tool number 1.
So it's really important that the right number is like the right spindle physically in the end, like that the right like the right spindle is at its spot, at its right spot.
That
the way that when the machine grabs, it goes to get the right tool. But does this number in the end does it matter if it's now like this number 1, is it the first one used, or can I change this?
Actually, you are, yes, I like what you call it, with a disclaimer that I don't want to complicate things. But you can, as long as there are 6 tool holders for the machine, or the machine has 6 tool holders, and you can assign any tool to any tool holder, as long as you are dead certain that they are all positioned correctly in the tool holders. And I like to make it like as less complex as possible by having the first tool in the first tool holder, counting from the right to the left of the machine when standing in front of it. But Jose is a master of both Mastercam as a CAM software and the machine as such, and it is not uncommon for him to just look at like, okay, I see that number, the tool I want is in tool holder 4, then I'll just assign tool number 4 to it, and then it fetches that and moves that. So that's depending on experience, you're free to like have you can begin with 6 and then go to 2 and then go to 4.
But it's easier to keep it structured, and
yeah, it's also easier for me to verify the validity of the toolpaths if like it's 1 2 3 or 1 2.
That's true.
Yeah,
that's true.
So now when we select the tool, all of these will be reset to the default values, and the default values are not to be used as such because they are not made in respect to a certain material or so. They are only default values. But since we for this it's actually okay, since it is tool number 1 and we intend to use this in tool holder 1, it's totally okay to just leave it as this and then continue on with the spindle speed and the feed rate and such. But I want to show you here that after assigning the tool or selecting the tool, when you do that, you behind the curtain, or what to say, behind the curtain, you actually make a duplicate copy of the locally stored tool from the tool library to the tools that are used in the documents. So now to make this clear, when you press select again now, then you see that you have in your documents, in your Södertälje 3D model, you have this here. And that is a separate duplicate. Changes you do on this one
does not affect the one in the library.
Does not affect the one in the library. And the library is actually locally stored. So like you can make any changes you want to the tool library, but if you want to keep it like in the way that it is defined, then you can just make sure to do this procedure. Because now when we have already assigned a tool from the tool library and open it again here, we can select this document tool, and then you can double click on that. Sorry, I actually instructed the wrong way. If you select again, it didn't make any difference. But if you right click on that one,
okay,
and press and click edit tool, yeah, then it's now you're free to change. And under post processor, you can change the number. So for this one, we will be using tool number 1, since this is the first tool that we are using, and that we will put in tool holder number 1.
Yeah.
And like you see, if you see these icons, it means that I hope you're okay with this.
Yeah, sure.
Yeah. It means that this value is calculated as a function of something else, and that is because the number, the length offset, and the diameter offset, they are all like you can assign different values to them, but when you change the number, you can change it to 2 just to test. You will see that the rest also changes.
Okay.
Like that. So you don't need to worry about the length offset and diameter offset. You just have to make sure that the number is correct. Yeah, and as you know, this is tool number 1, so we pick 1, and then we can press accept. It's like that's the only configuration you need to do or make sure for each tool, and press selector. But then it's good to do this beforehand, because when you select it and confirm the selection, all these values will be reset to their defaults. So if you do this as a last thought, then you will have to input those again.
Okay.
All right, because now we're getting to the really interesting stuff, because now we have selected a tool, a 16 millimeter flat end mill, And now we will have to set adequate feeds and speeds, so-called. And that is simply the feed rate is how fast or how quickly the spindle and the tool moves through the material, and the spindle speed is how fast it turns around. And these two factors, along with how many flutes that the tool has, how many flutes, how many teeth, there's an equal amount flutes and teeth, it will determine the so-called feed per tooth, or shipload per tooth is that's what I have been learned. That's what I have been taught. Shipload per tooth, but that is feed per tooth. The feed per tooth or the shipload per tooth, that is the core value, but it is the result of the feed rate, the spindle speed, and the number of flutes. The shipload per tooth is simply how many millimeters are each flute for climbing and milling into the material. Like if you have one flute, then it's per revolution. If you got two flutes, then it's like twice per revolution. And since each tooth has a corresponding flute with an extraction channel between the flute and the next flute, then it's also like the amount of material that gets extracted. So both milled and extracted. And simply put, the harder the material, the lower the shipload per tooth should be. Depending on your confidence and experience, you can like have the same shipload per tooth, but if you both increase the feed rate, the speed which the tool moves through the material, and the rotational spindle speed, you can still have the same shipload per tooth, but at a more aggressive feed rate and spindle speed. But as long as you maintain the same shipload per tooth, then the relationship between the cutting, the milling, and the material is still retained. But then, like I said, like depending on experience and confidence, like you could start like slower, but having the same shipload per tooth. So now this will be interesting because we don't know precisely what wood this is, but what I'm reaching to, or like, is that no matter whether it's beech or alder or birch, it is hardwood, and it is not bamboo, it is not oak, I presume now. Oak and bamboo, even though like bamboo is grass, but like very, very hard, and like very, very hard, and oak is relatively hard as well. We will be searching for and using parameters that are fitting for hardwood generally. And then one can always during the actual operation or the actual milling, one can adjust the feed rate. From initially it will be run at 100%, where 100% is the feed rate that we have set in the toolpath. But it can be reduced from 100% to any percentage. It cannot be increased, just so you know. The RPM of the spindle speed can be increased and decreased as you want, but it will be by default set to what we set in the toolpath. So what I'm saying is that we can use what we find reasonable for hardwood generally, and if we find tomorrow that the end mill is making noise that we don't feel pertain to an adequate milling, then we can reduce the feed rate or increase the spindle speed, depending on what we find reasonable. And the same if we think that it is burning, if we see like not flames, that should be like we should not have set a ship load per tooth that allows so much rubbing so that it will turn into flames. But like if we pause the operation and we see that the surface finish is a little burnt, or not burnt, but a little rubbed or like dark, then we can increase the feed rate while maintaining the same spindle speed, or decrease the spindle speed while maintaining the same feed rate.
Okay.
If we go back to the Google Chrome to the Google Drive document, and then if you go back to KTH CNC to the root directory, and then the community feeds and speeds document, then we can see here that we have some. See, yeah, I see that. All right, perfect. And the run date will be tomorrow at the 30th.
Yeah.
And the material will be generic hardwood, or will it be? You can say just hardwood, and we will not know because Henrik or any other who are more proficient than us in the art of the different material types, they are not there. But it's good with the hardwood, and the stock material thickness is 48 millimeters. Was it so? Yeah.
Where did you see this again?
See what?
The thing. Okay, yeah, no, sorry. Yeah, the thickness is 40. Yeah, that's true. That's right.
Yeah, that's the material thickness, and one can see here that I just know that this 90 millimeter material thickness, it was borderline too thick for the tool that they used, but also for how deep they cut. You see that they cut 73 millimeters. So it was like, and the maximum said travel height is it's on a number of factors, but it was really borderline too much. But we had to adjust the dust extraction attachment a little up, because that was the lowest point, and that gave them another millimeter to run that.
Okay.
Yeah, but I would say that that's like it's borderline too much. And the total depth of cut, that will be, let's see now, it should be, isn't it 45 millimeters? Yeah.
No, I don't. It's less because we have the base.
You
but
are right in that.
We didn't check how thick this is.
It's that's like a good thing to do. Now we saw, like, we had visual feedback that it was more than 3 millimeters.
Yeah.
But it's good not only to trust that visual feedback. I think that we can actually now we're in the middle of toolpath authoring, so I would not do it. It's okay if you open Rhino again. I know that it's like a little back and forth, but
it's fine. I think it was so.
And I just want to say, Carl, as well, that tomorrow we have the booking is for the whole day, but I suggest that we don't make it like an 8 a.m. meeting, perhaps.
I'm totally fine with this. We don't have to make it at 8 a.m.
No, okay, good. All right. So to find the lowest, what do you suggest?
Well, we can make the bounding box again.
Yeah, but the bounding box will not tell us what the lowest point of the.
No, but then just to calculate it from the top.
Oh, okay. Yeah. But will it be? You can actually, if you go to right viewport to like a right viewport, then we can here identify perhaps. Yeah, the lowest point seems to be there.
Yeah, but you cannot do it like really mathematically, like.
Can you not?
I mean, there must be a way. I just don't know.
I was thinking that if you make a line, and then if you begin, I was thinking if you like, if you
move.
Yeah, this is also. But then let's.
It's like the first point it snaps to. But
yeah, that's really good. And then move that down, or I say move down, but actually move up to the bounding box, which is not here now. But
we can quickly. Now we have this.
Perfect.
Which is the intersection between here and here.
Yeah, and it's 40 millimeters.
Yeah.
Or I would really like round that up to 40 millimeters.
It's more like to keep track of it.
Yeah.
Or.
Oh yeah, but it's also to like identify where it goes borderline too much.
Yeah.
And also depending on the tool used.
Yeah.
To like, I think that that is what is like the whole of this document is just that like you don't have to feel the weight on your shoulders, that you have to like know every possible circumstance for every material, but like if you look at how someone else has milled a similar material and then you look at the comments and they say that it was super, then like it's good. The comments are the furthest right. Let's say. All right, so we have a total depth of cut of 40 millimeters. That's good. And the bit used is number 25. And then if you would like to, that I can do that later on, but you could, if you select this one, or that one, and then you just press Control Alt V, then you copy the format of that block.
Control Alt V.
If you undo that, and Control C first from the one over there, exactly. Or yeah,
I'm just trying Control C, Control V, or Control Alt.
If you select the cell, one, and then Control C, then you copy all that cell. But then you only if you press now Control Alt V, then you only adjust the format. But I guess that since it's just an empty cell, then it would be okay to paste the other one as well. And since you're using the same bit as before, you can just copy the cut diameter and number of flutes. That's one.
Yeah. Feed, no, it is not.
All right, and now we come to feed rate and spindle speed, and the ship load per tooth is automatically. Actually, I can see here that you can, if you'd like to, you can Control C that cell. And then you can paste it both there and the one below. And it's divided by 0 because we don't have
anything.
But here now we can find now that if we go to the left again, so we see the different materials. Then we see here we have bamboo wood, we have birch plywood, and I know that birch plywood is not the same as birch hardwood, but it's still like an indicator of like a segment we could. Because that's birch plywood as well. Yeah, thanks. All right. So if we go a little to the right, I see that perhaps I should have ordered this a little different. Well, yeah, so you can see the ship load and in the same as the same, but it's okay. If you go to the left again, and we can select. Let's see here, bamboo is 14 and 15. If you press or click this 14 over here, okay, and then it's 17. Good, because then we can look at the ship load per tooth. And so 17, it's 0.05 here, the ship load per tooth. And that's like the ship load per tooth is the most valuable guiding indicator of a good cut or not for durability and finish. All right, so birch plywood was 0.05 millimeters per tooth, and bamboo was rounding this to 0.02 is wrong, but 0.03. So like somewhere around there. Bamboo is really, really hard. It's harder than oak to mill.
Okay.
And birch plywood is not it's not equally hard, but it's not soft either. And I would say that birch, or now this is not verified to be birch, but hardwood, it would be somewhere around there, like somewhere in that segment between 0.03 and 0.05. So it would be like no unreasonable order of thoughts to estimate it to be around 0.04. And this is like a good thing about this table, that this community-driven table is that like we can make these interpolations, even though no one has, for the duration of this document, milled hardwood. We can still like interpolate a reasonable amount of ship load. And then since this is a new material, then we will make sure to like have a more a moderate settings, but still an adequate ship load. So we can try. Now this is like in the beginning it's guesswork just to make it right, but we know what we're aiming for. We're aiming for about 0.04 of ship load per tooth. So regarding feed rate and spindle speed, with the number of flutes, and one should also take note that the number of flutes, of course, they adjust this. So if there are many flutes, then to get the ship load, a comparable ship load, as like with the 2 flutes, then one would need to be a little slower with the spindle speed, because it takes 3 tooths per revolution as compared to 2 teeth per revolution. All right, so we can take perhaps then the same feed rate or about the same feed rate, so we can take 1000 millimeters per minute. And then regarding the spindle speed, we can take a little slower than, so perhaps 14,000. And see, it was actually quite off. So to increase the ship load, we will need to either decrease the feed rate or increase the spindle speed. And I would say that the feed rate, it's actually a little high perhaps for our first run with the new material. So we can take 900 or 850.
850.
And yeah, that made it like even further away from our intended ship load, but I figured that the feed rate was a little high for a new material that we don't have verified, so we'll take it a little more moderate. And yeah, and we can
decreasing this because it's dividing by this. I think so, yeah.
Very good. I see now that this is a very moderate. I think we should increase it a little because we should be, or is it so? Yeah, we should be more. No, yeah, we should be close to 0.04. Was it that? Was it so? Yeah, okay. Yeah. I was thinking in the wrong direction. So
we could of course go with 900 then.
Yeah, because we don't want to go too slow with the spindle speed. We can see here that here we have tried 8,000 and even as low as 5,000 is also, but that is in styrofoam, if I'm not remembering incorrectly. So 8,000 is good. 0.04. let's see now, if we increase the feed rate, then the ship load per tooth will increase as well. So perhaps have 1,000 there. So we will perhaps reach 0.04. Yeah, and then we can increase the spindle speed a little to even it out to 0.04. Yeah, I am satisfied with that. All right, because now that we have calculated all of this, we can simply insert, and I just want to say that tomorrow when we mill, we can start like when executing the toolpath, we can initially try it with like 80% of the feed rate just to feel it and like listen to the material being engaged by the router bit, and just to make sure that we like don't do it blind, but actually like take in what we see and what like
the feedback, looking if it's
but this is great to begin with now. All right, and the maximum depth of cut, that is, the harder the material, the less of a deep, what do you call it, the more shallow, shallow each maximum depth of cut should be. Because that's like the 3D adaptive toolpath. It's the logic behind it is that it goes down the maximum amount. That's called the roughing pass, not to be mistaken for the roughing toolpath, which is like so the roughing pass of the roughing toolpath will be the maximum depth of cut. And then I think it was for bamboo it was 13 or 17, but no, let's see, 14 or 14 and 15, and then 17 was birch plywood. So for bamboo, for the roughing toolpath, it was 3 millimeters. And 17 for the birch plywood, this was 5 millimeters. Yeah, so technically we could like try with 4 millimeters as a maximum depth of cut, but this is it's a new material we're milling, and I would rather be a little more moderate than a little more aggressive. So I would say 3 millimeters, the same as the bamboo. And then like if everything goes smooth, then we know that until next time that we can go like, because the maximum depth of cuts, it mostly affects
the bit or the
it mostly affects like how long the machining will take, because like if you make 1 millimeter, 1 millimeter, 1 millimeter, it will take 3 times as long as 3 millimeters. And then, all right, and the simulated runtime we will input later. All right, so now as we have those parameters set here, it's quite good, because now we could have done those like independently in Fusion 360, but now we have like compared with already with the reference material, or like the reference, so it feels good. And now we can simply input this. So the feed rate 1,000, the spindle speed 8,500, and the maximum depth of cut 3 to be input later. So we can go back to Fusion. So now we'll set the spindle speed to 8,500. And we'll set the cutting feed rate. Was it 1,000? Yeah, I think it was 1,000.
I think so, it was 1,000 in the end, yeah.
Good,
yeah,
and the feed per tooth is good here.
Just under 4.
And the leading feed rate and the lead out feed rate, they can be reduced, but I would not say that it's necessary. It's when the tool goes from being non-engaged to engaging in the material, then it's like can ramp up in speed from a lower feed rate, but it is not necessary as long as the like one could like make this different and like maximize or minimize the time it takes. But I find it better to like find reasonable amounts and then let it do those. But I'm saying that for the lead-in feed rate and the lead-out feed rate, but for the ramp feed rate and the plunge feed rate, I'd say that it's that is good to be like even more moderate. Like you see, it gets like a third by default.
What is the difference between the ramp feed rate? What is the ramp and the plunge feed rate?
The ramp feed rate is it's a little difficult to perhaps demonstrate here, but the ramp feed rate is like going like this, like a ramp, or it can be it can be a helical ramp like this, or it could be like only like a simple ramp, which is like that. The plunge feed rate, it's like going down like this, in a much narrower angle.
Okay.
So I perhaps, since this is hardwood and it's hard, I could say that we can set the ramp feed rate and the plunge feed rate to 250, like 1/4, to be a little more moderate than what Fusion 360 automatically suggests. Yeah, we have set the spindle speed, we have this, and most of these are like automatically calculated or automatically adjusted. But setting the spindle speed and the cutting feed rate, those are like the main things. And then just making sure that the feed per tooth is the same as you had already calculated. Perfect. That's like the feeds and speeds. That's the most exciting part, perhaps. But the other ones, the other tabs here are equally important. So if you press geometry here, we can see here that the most important here is rest machining. You also took interest in the machining boundary. That is very important for succeeding toolpaths. For this one, we can simulate and see what it looks like, and if it's okay, then we don't need a boundary. But one could, if you would like to hover over this, over the machining boundary. So there, hover over the option, the none there. One can see that there are different ways to constrain the toolpath. But we can, if you click that, click the options there, yeah.
Here, sorry.
Yeah, you can select, or we don't need to do that now because now we have no need to do that. So we'll do it for the second toolpath where we have an actual need for it, or an interest in doing it. Yeah, but rest machining or remaining stock machining, that is important because one could make like independently authored toolpath first with a larger diameter bit for roughing and then with the finer, and just make them like cover the same area but like doing the same twice. But if you have a rest machining or remaining stock machining, which is on by default, you actually, for succeeding toolpaths, take into account what has been already milled away previously. So here you can see that the source is the from setup stock. Yeah, but that's the important thing here. So we can go to the next one, the next tab, and here we can set retraction heights and clearance heights, and the defaults are perfectly fine. It means that for the retraction height, when the tool is not engaged in any material, it retracts 5 millimeters above the highest point of the stock, or like
it's like a safe zone.
Yeah, like a safe zone.
Yeah.
And then when it's only 5 millimeters above when it moves like to continue to mill, but in another part of the model. But when it moves to change tools, like between different tool paths, or when it moves
and it's a clearance.
home, it's a clearance height, and it's an additional centimeter, and it's just an extra like layer of not worrying or safety. Yeah, and these are perfectly fine as defaults. So we can go to the next tab, And here, like the tolerance that you see here, like I said, Fusion 360 will analyze this model and see where it, or yeah, it will analyze these models, how to effectively mill it. And the tolerance value will determine how closely it will take heed to the original geometry. And I find 0.5 millimeter sufficient, just simply because like I would not be able to tell the difference if like for an angled curve, if that had been segmented in 0.5 millimeter segments, or if it has been segmented in 0.1 millimeter segments. So I find it reasonable. And then let's see here, the next one is, here you can say the direction is set by default to climb, and that is how you can perhaps see. Actually, it did not show in it did not show in any like any clear way the difference there. But the next one is a central one, because that's the maximum roughing step down and the fine step down. And now it's set to default 10 millimeters. And we said that 3 millimeters is more reasonable for this hardwood material, which we haven't milled before. So we can go down to 3 millimeters. And by default, the fine step down is a tenth, 10% of the roughing pass there. But 0.3 millimeters for roughing is a little excessive, or like it's a little too little. Because if the intention is to simply excavate a lot of material, then one can have like a fine step down of perhaps half, perhaps half of 3 millimeters, perhaps 1.5 millimeters, or leave it at 3 millimeters. But what we leave in the fine step down, that is what which will then later be milled away with the finishing toolpath.
Okay. Yeah.
All right, and then we move to the last one. We can actually go down here, and you see here stock to leave. And here it's also set to 0.5 millimeter, both radially and axially. So in both the Z direction and the X and Y direction. And it's a good setting for the roughing toolpath, so as to make sure that even if some material is getting like by force extracted, then we have that like half a millimeter of extra margin, so that this finishing surface toolpath actually defines the surface.
Okay. Yeah.
And we can take the last tab, sorry. And here the most important is if we go all the way down, and then the helix ramp type is it's recommended. It's good. One has to take into account that the helix, it can be quite hard to visualize, but the router bit is circular. I say it's circular, and it is circular. Yeah, it's circular. When moving in a helix, in the beginning, the radial diameter of the router bit has a lot of contact. I don't know what it's called, the circle sector, circle sector. The percentage of the diameter, or not the diameter, sorry, the percentage of the edge.
Like the volume of what's touching when it's
has a lot of contact. So that means that in the beginning it will move relatively slow,
because it takes also a lot of material away.
But then since it's doing in a helix, and the larger the helix gets, the less the contact area is. And since the adaptive toolpath is adjusting the feed rate depending on the ship load, then it's like I always get a little like, or always, but like you can get a little like, oh, it's moving too fast, it's moving too fast, it's moving too fast. But it takes into account the amount of engagement to the material. So, but like I said previously, since this is the first time we're doing this toolpath with this material, we will begin at 80% feed rate, and just like feel it from there, and then increase it if we want, or keep it. And if we keep it, we will adjust the community-driven feeds and speeds table according to that. So we have an error here, but it has failed simply because we have this open and it tried to, so it was no significant error. It tried to make an autosave. And all right, so did we have the helix ramping here? I think so.
I think so, yeah.
Good. All right, if we go all the way down, I just want to make sure I don't forget anything. No, and and here the no engagement feed rates. Now it's set to the same feed rate as the cutting feed rate, but here we can set it. Actually, we could set it up to 5,000 millimeter per minute, but we have no use of like rushing. It means that when it's retracted and it's not engaged in cutting, it can move really fast. You can set it to 2,500 without worry, or like we will see that it speeds up then when it but it will save time. All right, and like I prefer to like better check twice and cut once, better check twice and simulate once. No, but it's better simulate twice and cut once, and it goes on progressively. So we can go back to the first tab and just like scroll through here. Yes, spindle speed is good, and cutting feed rate is good, and ram feed rate is adjusted, and plunge feed rate is adjusted. And of course, the plunge feed rate will not be used since we will be ramping in a helix move. But like it's good practice to adjust both, just so that you don't only adjust one and adjust the wrong if you want to adjust those. If we go up to the top, we will just make sure that the tool number is correct. Yes, this is the first tool we will be using. All right, we can go to geometry, and we will not have a machine boundary for trying this out now. And rest machining is from setup stock, and ignore cusps, and adjustment offset 0.5. Yes, looks good. And like I said, we could, if the toolpath produces unwanted excursions into the area where we have more material, then we can adjust the machining boundary so that it stays in the boundary box. Or all right, and heights. Yeah, this is perfect. And with the passes, we have adjusted the tolerance, and let's see, and climb direction. And the maximum roughing step down is 3 millimeters, and the fine is half of that. And the stock to leave is 0.5 millimeter for the finishing toolpath to define. We can go furthest down. Yeah, very good. And the last tab before confirming is the linking, and perfect. Yes, we adjusted the no engagement feed, and the feed rate and the ramp type is helix as was default.
Yeah.
All right, we can press OK, and pressing OK will then let your computer calculate the toolpath. So you see here that there's a percentage, and there's like a...
It's amazing.
It's really nice. And now one cannot expect like very nice results from this roughing toolpath since it's such a wide diameter bit and everything. But one should anyway go to actions and simulate. Oh yeah, it says so there.
Simulate.
Yeah. And then one could go to, I think it's info here. Let's see, draw to the info, and there, if you go furthest down, it says no collisions, and that means that it has been simulated. It does not detect any collision between unmilled material and the tool, but it only takes into account the material that is defined in the stock setup.
Yeah.
All right. If you go to statistics, you can see the time it takes. It says here that it takes 1 hour and 23 minutes. That's quite a long time, for especially like since this is only a roughing toolpath. But I will not disqualify the settings solely because of that. But it will be nice to see the simulation here. Perhaps we have like you know, we set the roughing pass down to 3 millimeters, but then added like 1.5 as well. The electric toolpath will do that. It will go down to the maximum pass down set, and then it will go up in increments as we set. So if one would have left it at like 10% of the maximum step down, it will go down, like we can say the default values. It goes down 10 millimeters, and then it goes up one and up one and up one until it is up there at like -10 + 9. Yeah. So perhaps we could, for this roughing, like since this takes close to 1.5 hours, we could see if we really need the like fine step down of 1.5 millimeters for roughing. But if we go back to display here, we can actually simulate it like not in real time, but so we go back. Yeah. And now if we press the play button here, we can see. But I would actually, if we pause right now, or if we pause, it looks good, but you can show the stock. Like that, perfect.
Okay.
And then we could, if you want, hide the model. And then we can see only what we will get according to this toolpath. So.
Okay, and this yellow line, that's always when he's going back like this.
Yellow lines, that's the no engagement. Green lines is the entry, like lead in or helix. Yeah, I would say that this is far too like fine step down. This 1.5 millimeters, but you could let's see, I will clear here. You adjust the speed. You adjust with this slider here. So now it's there, but you could increase the speed or decrease the speed when it's played.
Speed of the demo, or
speed of the simulation. But if you go a little slower, because now I have a hard time seeing if. Yeah, so you can actually you can go a little faster.
With the.
Yeah, with that exactly. Because like the toolpath in itself looks really good, but then like one can see here the steps here. I made it. It was quite not a representative line there, but like it's really for a roughing toolpath, it's perhaps a little too fine.
Okay, yeah.
But we can see this if you. I know I said it was too fast earlier, but if you increase the speed a little, and a little more. Yeah, yes, because I want to take a sneak peek on the end results. Yeah, we can do like this. This is perfect. And then you could, because now the toolpath is it's obscuring more than it's showing. So you could disable that there.
Yeah.
Yeah, but one can see, like here you see that the roof was not that accentuated. There it was a little more, but then again, this is the roughing. This is the roughing tool.
Yeah.
I mean, it's very like not end result worthy, but it's got some
Just
very fine stepping here. Like,
so would you change the stepping and?
yeah, I would keep the 3 millimeters since since it's hardwood, and I know from experience with the bamboo that 3 millimeters was like it did sound not dangerously vibrating or such, but like it was a hard, bamboo is quite hard as well, but but this is the end result of the roughing toolpath.
Yeah.
And if you enable the toolpath display again, here to the right, you can see that if you click on top over here, you can look at it from the top. And then you see that over here, it actually goes in the material that we spoke about, that it's like here it's in the air.
Yeah.
And here it's in the air, and here it's in the air, but here it's and I think that if one does not like want to keep this material untouched, I think that this is okay. Because it's leading. We can simulate this again, or like it's already simulated, but we can replay this and take a look on where, if you press on this corner again. Sorry, now it's a lot of. If you press on this corner again, you can press the home here to get, to get back here. Okay, yeah, that's really good actually, because as I see this is actually a lead out, and then it retracts, because it would not plunge this deep. But we can evaluate this by going back.
I have a little problem that I have to do it like this way. I cannot reach to the.
Yeah, one thing I was thinking as well, that now since we have added a toolpath, which perhaps we will adjust, I think we will adjust it, at least get rid of this, but we can save it, like it has not been saved yet. So I think that like that's good. It's good practice to just make sure that we don't lose the progress that we have done.
Yeah.
Yes, so we can press close.
Okay, I thought it's gone. And in how do you save this one?
You can press this button or Control S, I think also.
Yeah.
And then you can like keep it at user saved. For each version, there will be like a versioning.
Okay.
Yeah. And you can have a version description. Like if you're working, collaborating in a team, they can know like I added this, or I.
Yeah. So okay.
And then you see here that it changed here. It keeps the versioning there. You can change it, but now it's version 2. Great. All right. I think that we should do the boundary, just to like since we are aware of this material, and we can. I see like 2 areas of interest here. This one, that line, as well as these. We will have to make positively sure that these are retractions from the bottom up. It would not make sense if it was from the top down. But like here it is from the top and down. and
Yeah.
it looks more like it there, but we will have to simulate it once more just to make sure that. So if you press either this button directly or actions and simulate it the same thing.
I go to the end.
Yeah, we can go if you press play, or if you go there.
I mean, yeah.
Here it's still perfect, or what's it? Did you see? Was that because it looked like that actually was a plunge?
It actually looked, yeah. It's
and that's like one really good thing about simulating, that if you see that it would not to declare now whether it would like be a critical disaster or not, it would I would not dare to say yes or no, but that is something we do not want. What happened there?
Yeah.
So then it's really good, because then we will like you can pause and close, because this we will need to make a boundary, and that is perfectly fine, because then yeah, this was a good example of like when you have to intervene and like not turn a blind eye to this. But so we can press close here on the simulation, and we can show again the model. Oh, sorry, if you press that, yeah. And now, since you selected the model, it's no worry, but you have to select this setup again. Perfect. And then either you right click or you double click on the, not on the setup, but on the toolpath, since we will be editing that. Yeah, I think you actually double click on the, you can press edit on the top here, or double click, I think. But here, we will be needing to adjust the, is it here? I think it's there. Yes, the machining boundary. So select from none to bounding box. And then the tool containment should be, the tool should be center. Or wait a minute, if you hover again, like this, I like this about Fusion, that's like we can test here. Exactly, if it's outside, then it can move on the outside edge of the boundary. I would still say that we pick center. The disadvantage of outside, as I see it, is that it might still be susceptible to entering from outside. But if we choose center, then we are sure that at least the center of the bit will always be, so that it doesn't engage more than 50%, like half of the diameter. Perfect, and we don't need to adjust the additional offset. It should be like on the at the maximum on this boundary. You see this yellow.
Yeah.
Yeah.
So it should not go over it.
It should not go over it.
Okay.
Then we can, since that was the only thing that we changed, and the rest was good. Yeah. Oh no, sorry.
It was the 3 millimeters, like.
Yeah, we can actually, if you select 3 to that as well, then it will understand that this, if the maximum is the same as defined, then yeah. So now you can press OK, and then it will calculate again. And now, yeah, you see that it's a totally different
okay,
because now it's now it's like calculating it how to do it without extending beyond. Yeah, so so as you can see, it leads to drastically different results, like in terms of what it will cut. Yeah, we can check first info and go down. So just make sure that it doesn't register any collisions. If you go down here on info.
I'm sorry.
There, it's non-collisions. And as we see here, this will take longer to mill since it will not extend beyond the boundary.
Yeah.
But that is if one has to choose between the expense of time or the expense of security, or then it's better to take it a little, let it take a little extra time, and then we can hide the model if you want. It's just to get a clearer view of the simulation end result, and we can start the simulation. And we see that it begins with a helix.
It's really interesting because it seems to be a really different approach.
Yeah, because now it's not. We force it to ramp each layer because it will not enter from the outside.
Yeah.
And I'm just thinking because I'm just not speculating. I'm evaluating if one would allow it to enter from here and from here and from here, but disallow it or forbid it to enter anywhere here.
Can you manage this to say okay, you can enter from certain sides or from certain points?
That I am not aware of, and for this since it's 10 minutes to midnight and we look forward to do this tomorrow, I would say that we rather take the hit of 10 more extra minutes of milling time. I guess that it could be reduced further, of course, since now we have 3 millimeters heights. But
I'm just curious to see what are the possibilities and where.
But Carl, I encourage you to not tonight, so that you are let's make sure that we both are alert tomorrow. But since Fusion 360 has this good user interface, you can get an estimate of or get a you can get some preview of what changing a setting will get. You can test out
it's a bit the render.
You can upload this same model as a separate document file or a separate project file, and then test out with other parameters and with but if it's okay with you, not for tomorrow.
Sure.
All right. So now we know that we will be making a lot of helical entrance, helical ramping. If you allow it to finish to the end, just because it's so little, and just so we can verify that it's.
Should I take away the?
Yeah, we if you go to display here, you can.
Toolpath, right?
Yeah, if you want, we can show it again, and then in the end. Just looking here.
It's interesting because the whole, the helix and the idea to. We talked about it before, and it's nothing new, but the way to see it, it gives it another. I can really imagine it now. It's nice.
We can display the toolpath again just to make sure that it's, and then we can by showing in the top view, we can just make sure that it's not extending. No, it's not extending anyway. So that way we make it less optimal in terms of time by forcing it to make helical entrance points instead of entering from the outside. And for the final model, we can experiment further with that. But for now, let's if you are fine with it, we can be fine with that the roughing is like this.
Yeah.
All right, then we can close this. And now we should add another toolpath, the finishing toolpath. So either with the toolpath selected or the setup selected, but the thing is to be in this setup. You add another adaptive. adaptive 3D, adaptive clearing.
Okay.
And you can, if you want, be in another. You can press cancel and be in, or I don't know. You don't perhaps need to press cancel, but be in another view because now we don't see.
Oh.
Yeah, and you can show the model as well.
Yeah.
All right, so now we select a tool, and we can go to the tool library. And now, now it's sorted in diameter from largest to smallest, so we can go down a little. And then we want, of course, depending on what you find, what you think is the best. But a ball end mill will be better at producing a smooth surface, but will produce also scallops, which one will have to like sand away, but sanding those away are easier than to like make a stepping model or a flat end model stepping smooth. But then it's different like aesthetics. Either you like a flat steps or more of a smooth.
Then for a ball end.
Yeah, and then like the smaller the diameter, the less sanding post operation, but also the more time it will take to fabricate.
Yeah.
We can test, like, since this is a test, and so we can test with. Let's see here. We have a ball end mill 8 millimeter there. It's got a flute length that it's like what do you call it? Sufficiently long, but we can also, let's see here, next. It's like I see now that since this is decommissioned, the 6 millimeter one, the next one is the 4 millimeter, and that only got a 20 millimeter flute length, and that is less than the maximum. But still, it's really long, as one can see here. But it's got a shoulder length of 27 millimeters, and I don't know if 27 millimeters it's less than the maximum cutting. So picking between the 4 millimeter and the 8 millimeter up here, I would say that 8 millimeter is much more fitting to the possibilities of milling the whole way. And like we see here, it's got the same what do you call it? The same shank diameter as cutting diameter. So that's also very good. Then we like know beforehand that we don't we will not encounter any
problem,
any collision between the shank and the unmilled material, because everything above the cutting will be cut by the okay. Yeah, we can definitely try this. Okay, so select it, and then select it again here so as to change the tool number. So right click on it and edit tool, and then go to post processor and press 2, or press 2, but type 2.
Yeah.
All right, and accept and select. And now I see here that tool number is tool number 2. That means that we have to put in the tool holder 2. And we also see here that it says tool 1 and tool 2.
Yeah.
Good, great. All right.
Middle speed, we take the same values as for the other one? Because we have the same material, or not, especially?
Not necessarily, because this is half the diameter. And like generally, like the larger the diameter, the larger ship load you can have. So one thing that one could do is like retain the spindle speed, but lower the feed rate. Thus you would get a lower ship load per tooth, and it's not linear, so it's not like half the ship load for half the diameter. It's advisable to not go as aggressive with a smaller bit, because there's this thing called deflection, which is if a router bit while moving through, if like there is too much lateral force, then it's boogie woogies. And the smaller the diameter, the more susceptible it is to deflection. So it's good to be a little more moderate about smaller diameter. So if we go back to our Google Drive community-driven chart of feed rates and spindle speeds, we can just if you want, you can copy all of this to the next one, exactly. So to the next row, exactly.
Now we have another bit.
Yeah, what was that? Or what is this? It's you can press select now, and it's number 11.
11.
And the cut diameter was 8 millimeter. Did it have 2 flutes, or how many had it?
I don't remember.
2 flutes.
2, yeah.
Yeah, and then we can copy the values from above, because then we copy the equation as well. So
yeah.
And then we can reduce the feed rate to, yeah, you see here that since this, you can look at the ship load per tooth, that it's much more aggressive also, because it has fewer flutes. So that is one thing to also be aware of, that we will have to adjust the spindle speed as well, not only reduce the feed rate to reduce the risk of deflection, but also increase the spindle speed.
To go with both, yeah.
Yeah, but I think that we will do the other way around. So we will increase the spindle speed so as to reduce the ship load per tooth.
Okay.
So perhaps from 8,500 to perhaps 11,000. Try that and see if it's oh yeah, or 10,000. I see that it's yeah, we can try this. We can try this.
Should we do with 11?
10,500 perhaps. Like all of this can be adjusted while operating. Oh, but now it's was 15,000, so 10,000.
Yeah, not the same.
Yeah, I think that this is reasonable. A significantly lower feed rate. Yeah, but not like the lowest that there is, or like in the list here of past experience. And the maximum depth of cut should be, let's see here now. We know that it left 1.5 millimeters. No, it left 3 millimeters.
3 millimeters, yeah.
Yeah.
So it cannot go more than 3 millimeters.
No, but I also think that max is. I also think that since the deeper you go, the more like potential lateral force and deflection there is. So perhaps.
But is there really more? But that's. Is there really more force on the? Because the whole head goes down. No.
The whole head, the whole.
I'm not sure about the terms of the machine, but like the bit it will be like attached by the
spindle or the collet, or yeah.
So the like the spindle and the thing that grabs the spindle.
Yeah, the collet.
The collet, like in a sense, the collet goes down with the spindle. No.
Oh yes, but
so the distance always the same, and while traveling, the force will always stay the same, even if it's steeper. No.
I think that the force, that the lateral force is proportional to how deep it is in the material.
Yeah.
because like it will engage in less or it will engage in more. But so since this is a little smaller or half the diameter, but it's not like a linear equation or something. It's just like we estimate this and we adjust. We cannot adjust the depth of cut or the pass depth during the run. So that's why I think it's good to like rather be a little more moderate about those values that we cannot adjust during operation. But I would still say that 2 millimeters is I don't see a problem with that. Like I'm thinking about 1.5 millimeters, but we can take 2 millimeters because it's also a ball end mill. So the thing I spoke about, like the lateral force, and it's a little reduced by the fact that it's got a radius on its lowest point. So I think the 2 is adequate. All right, now we have the parameters here. It's going to be interesting how long this will take, and perhaps we can adjust it a little faster, but we will see.
So we said spin speed 600.
No, spindle speed was 10,500. Yeah,
I'm confusing. Yeah, 10,500.
And the cutting feed rate was 600, like I said.
Yeah.
And the feed per tube is the same. And then we can do that now as well, that the ramp feed rate and the plunge feed rate are like 150 instead. All right, and then we go to the next tab. And the machining boundary should really have been, or we should really have that now. It should be the bounding box. And the tool should be center on boundary. And since we are using a tool of a smaller diameter than before, it should never extend further than perhaps actually this will turn into a the previous was 16 millimeter diameter, so 8 millimeters, and now it's 8 millimeters or 4 millimeters. So perhaps this will actually this will be interesting because we perhaps will need to change this, but like I say, you can also make an additional offset. We will not do that for now, but we will look at the simulation and see how it is, because as I presume it to be now, this setting will leave 2 millimeters on the side that will not be cut anything more than the roughing pass, because that's the difference on one side for the difference between but I'm not totally sure about that, but isn't it 16 and 8 is a difference of 8, no, perhaps it's 4 millimeters. But we will see with this, and we can adjust it with an additional offset, or we can we will see. But here it's good, or here it's very important that you change the source of the remaining stock machining from from setup to from previous operations, the first one.
Okay.
Because then it will take into account what has been
already taken away. Yeah.
It should be fine. It should be fine, even though it lost its unit. So 0, 0 is 0. All right, this is good as it is. And then the passes, the tolerance should be 0.5 here as well. But then the maximum roughing should be no more than 2. And the final step down can be 0. Actually, it's we will see how long it will take. Because like we can try with 1 millimeter, but I know that 1 millimeter, it's like to make it perfectly smooth, you need to go sub 1 or sub millimeter.
Okay.
But still try with 1. We can see what the results are similar.
Should I go with 1?
Yeah, we can try with 1, and then we can look at both the time it takes and here the stock to leave should be unchecked, so no stock to leave. It should be the actual geometry, since this is the finishing tool. All right, and for the last tab, we can have the no engagement feed rate set to 2500. And the helical ramp is good. So yeah. Okay, so we can double check all tabs here. Spindle speed, tool number 2, good. Cutting feed rate, good. And the other tabs, geometry is tool center. This we will have to perhaps readjust. Rest machining is from previous operations. Very good. And next one should be like we didn't change anything here, so it's good. And passes, we made sure to adjust the tolerance and the maximum roughing, and yes, very good. And no stock to leave. And for the last one, we no engagement feed rate and helix. Yeah, okay, we can press OK to calculate it. And I might be wrong about being worried that this will take a long time, because a lot of the roughing, or all of the roughing, but the roughing toolpath might have taken away so much material that it doesn't take that long. But I have a ominous feeling that this will take a very long time.
You think it will take a long time?
Yeah, perhaps, but you know,
Okay.
you always have to measure what you intend to mill, to fabricate. If it is,
because I have really no clue. Like I could have best chance.
This is something I just want to. Sorry, but this is something I want to. Do you see this area here? It did not mill at all there. And why? Simply because we left with the previous roughing toolpath, we left 0.5 millimeters for the finishing toolpath, but now we have as a fine pass down, or fine pass depth, 1 millimeter. So the finishing toolpath is authored with a pass depth that is higher than the stock left before. And we can it is already calculated, but we can simulate this and see what kind of results we get and at what time. But that's like, if you see something like that, then you know what you are seeing. It's so if you press actions here or simulate there, and we can go to info and scroll down. It's calculating collisions there. You see that it does there. No collisions, good. And with the statistics,
an hour and 40 minutes.
It takes an hour and 40 minutes. It's it was less than I expected. So
okay.
But now we're talking about is it 3.5 hours of milling time? With both toolpaths. So one has to take that into account with the final model, which is very much larger than this. Got equal height, or not equal height perhaps, but it's of equal scale. But this is a very small portion of it. So
that's kind of the whole reason why I'm trying this, to kind of understand what would be the time, and now maybe also thinking about stepping back in size, or how big does the model really need to be, because it's like if you have this, I don't know, extra 10 or 20 centimeters, which costs you an extra 3 hours, then you reconsider.
But do you think, Carl, that for tomorrow, I just want to what do you call it? I just want to tell, or not tell like that, but I just want to share that since it's past midnight, I think that we should prepare like this one toolpath, or like not necessarily exactly like it's has been like adjusted here. We can have it like I always want to say that I know that we had the ambition to make tomorrow like testing out different. I think that perhaps we can take tomorrow to test out this. And then I'm open for like testing other toolpath options for other days. But I think that like I want to be sincere about I don't want to like work all night now. So
no.
Yeah.
I totally agree, and I think it's. I mean, if we manage to have this, and then we can try this tomorrow, and then I totally agree.
Yeah. So now, since we are using this rest machining or remaining stock machining, you already see the previous result. This is the roughing, like you see. So like 1 hour and 40 minutes or what it was. But then we can, if you hide the model, then we can, if you press play, then we can see how it does with the. If you want to, you can in the display tab here, you can actually what do you call it? Yeah, you can hide the toolpath because we will
Wow.
open it again.
Okay. Yeah.
Yeah, but this is some. I will not like evaluate it too early, but this is some nice results. But sorry for asking, but do you recognize what is like this? You see that there are like.
I'm also wondering what it is. If he's just taking.
Oh, but yeah.
Oh
but
yes,
yeah.
that's the roof. Yeah. I also was wondering first, like, why?
What is that? It looks not, but now it looks good. It's I was just so I was for some reason determined that it was a landscape, and like, what does it do there?
Yeah.
Yeah. So and like this, yeah, you see there, and it might be a problem, it might not be a problem, but the reason behind it is because the stock left by the previous operation is less than what is actually milled here. So.
I'm also wondering, like, now having this like surface that ends up like this. So would you have to then send it manually a bit down or to get it smoother?
Yeah, because you will get scallops with a ball end mill. Now it's done. You can zoom in like without starting it again. You can zoom in a little so we can see, because yeah, it should be. And if you want to rotate, I find it easier to rotate by click and dragging this cube in the top right. So you can click and drag and you can see. Yeah, you see that like this is not. Is this intended? I don't know. Is
No.
that no?
No. This is supposed to be smooth actually, but it's also interesting because it means like now we're like at the scale 1 to 1000.
Yeah.
But if we go down to 1 to 2000, we're losing even more.
Yeah, exactly.
Yeah.
So yeah, and I won't be making the call for this.
Yeah.
You will of course decide yourself which scale you would like. Can you please like can you rotate a little bit more so I can see? Ah, okay, yeah. This let me guess. This was supposed to be like more.
Sorry.
It's okay. It's okay. Or can you? Oh no, yeah, but this was supposed to be more like this, or.
Yeah, like
Yeah, but that's the radius of the
bit.
Yeah, and I guess it's the same thing here in the like concave corners, like there. Yeah.
Yeah, but it's interesting because like it gives a bit of an idea of like how it ends up on here. Like it was supposed to be like also sharp, like how.
Yeah, but I do understand that like when finishing, when doing a finishing toolpath with a ball end mill, like this sort of like it might not be what either of you and I expected, or like in retrospect, this is what to be expected of a ball end mill. But like one like has like I have an image of a landscape model with houses. It's not that it's like have been a snowstorm and it's like it's more like that's there like distinction between like what has been placed and but not necessarily with different materials. But perhaps this is a reason to perhaps I don't really know if that is like I don't know if it's like an endeavorable path to take or not, but one perhaps could take in between these two, have a smaller diameter flat end mill, but then it will of course increase the time. But what do you think, Carl? Because we could of course try this tomorrow, like more or less like we have it here, and then we could evaluate the results and definitely test once more before the final model, because that's also we will not get any better results than what we have simulated here. And like you of course decide what the like qualities are of your model representing your project. But I think that this is a problem like with the snow. I think that's like a larger problem than the stepping on the roof or something like that. That can be easily sanded away, but those
and even the stepping on the roof kind of gives this idea of having maybe shingles, or like it's not even that harsh.
Yeah, exactly.
But it's, I mean, I think it's great to do because it's things I didn't consider before.
Yeah.
But yeah, I'm still down to test it to see how it looks once it's really like just like do the test tomorrow.
Yeah.
And then I'll have to think how. I cannot tell now how it will be for the final. Like in a sense, because it's also the question. Like I was more before, I was more into the mood of probably bringing it to even smaller scale.
Yeah, exactly. But
realizing that already on this scale we're like losing a lot of details. I'm wondering to what extent is it smart to.
Yeah. But one thing I want to bring up then is that in half the scale, there was this tool with half the diameter. That could be like, I know that it won't improve the matter, but you remember that there was a 4 millimeter ball end mill. But which was a little too short, or not like, I don't think it was a little, but it was like significantly too short to mill the whole. I think it was 27 millimeters or something like that. But with half the scale, perhaps that could work, and then you will get like the same proportion, or like half the scale, half the diameter. it should then look like this, but be smaller. And being smaller, it could be milled in less time, and perhaps in a. But I don't know. Like this is something that, if it's okay, I think we should not try it for tomorrow. But I think we should try this for tomorrow. If you like think that this is like viable for making you like take considerations in the route that you want to take the model of your project.
I think so. Yeah, I think so. That's not. I mean, it's yeah. Like concerning the final or like the final, this idea of having a final model, I really don't know yet, and I'll have to think still.
Yeah.
But for tomorrow, I think it's good to give it a try and to see. And I'm curious to see how it looks like, and also maybe then trying to send it like yeah, just to kind of try to do the whole process and having an understanding for it.
Yeah. Okay.
Because then like thinking about the final model, or like what's actually maybe also possible, like just talking about possibilities to do, is to take styrofoam, do the negative, like instead of now that we're like doing the opposite what we did, and then you can cast it.
Yeah, and that is really a really nice idea as well, because with styrofoam you can be much faster, and faster being like you can take the same amount of time but being like much less stepping. But with styrofoam you have to make sure that like the low grade styrofoam, that's really like it gets it has a large cell size, and those cells are ripped away really easy. But the more high quality ones,
the harder,
there's this one, I don't know, like if it's
blue,
still styrofoam. The blue is I think it's the blue. It's really hard. That's like but we can try this, and like I find it very because not to my experience, because my experience is so little. I said that this is like the first remote consultation I do. But I've heard from Letizia as well that like some students are like dead set on like, but this is the model that I want, and I want it done, and I want it like, and
this way.
I find it very it's very good, I think, that you see different opportunities for making this final model, and we can try this tomorrow. And if you think that it's good, then we can of course like improve this method and make it better. And if you think that perhaps we can try with this high grade styrofoam and make an inverse and make a mold, then like that's equally interesting. So
yeah,
I think that yeah, and I think also that like now we have done, we will of course export this these toolpaths into one G-code file. Yeah, I was thinking that like this was a pleasure, and we are not done yet. I don't want to like conclude, but I just want to say that this was a pleasure, and I'll gladly do it again. But at the same time, I think it's good that like now you have lots of tools to experiment with this, and you will also get this video, and like if you like, what's that, then you can
go down and watch it again. Yeah, that's true.
All right, but now we have simulated this, and we have looked at it, and we have seen its like pros and cons, and accepted it as it is. So we can press close here on simulate, and then we can show the model again. All right, and now it's important that if you only have the one of the toolpaths selected, when you export it, it will only export that one. So it's important that we that we select either you do that or you select the setup. I prefer to select the setup because I know that everything in the setup will get exported. And now I guess that we will have to download the post processor. It's not a big deal. It's in the same Google Drive in the Fusion 360 folder. in the Fusion 360. There's post processor, and if you download that, then when opening or when returning to Fusion 360, you don't need to open it, sorry.
Okay.
Then under actions, there's this which is called post processor or post process. Yeah, it's nice because I always I always click on that tab and open it, but so I'm a little like, so, oh, but is this the right? But it's of course those two that are used. And you see this configuration folder is the default folder, but if you press this button and relocate to the directory where you download, so I guess downloads, it doesn't need to be in a fancy location, and you just select folder. So you select folder here, and you're in the download, so then it will automatically find the post processor.
Okay.
So that's Jose, who is a PhD student, I think it's called. Is his doctorate? I don't know. He's a very masterful person handling the CNC very well. He has also made this post processor, which works flawlessly. All right, and then you can see that there's a default output folder, and this you don't need to change this because you will have the opportunity to redirect it after saving. But this is important to uncheck the open NC file and editor. The unit is document unit, and as long as the document unit is in millimeters, it's okay. And that's the only thing you need to verify here. When you press post, you will have the opportunity to rename. Now it has a default name of 1001 and a default directory of this, but no matter the settings of that, you can press post, and then you can change the file name to I usually do it like the material and the material and the what. Like if it has a project name, so solder atelier or any way you want it.
And then save it.
Perfect. And you can see down here the for the setup one, the like preview the machining time. And do you think that's 3.5 hours? Is that good? Like I know it's a lot of time, and I want to be straightforward with it, that you don't have to I know that you are eager to learn. But like for those 3.5 hours, you don't have to be, since you are relatively inexperienced, I will be there for the whole time. And thus you are free, of course, to to study and to direct your time as you want during the machining, but you are also welcome to be present and supervise as you want. But supervising is it's a little like bewitching. Like you can watch it and like you can really lose your in a good way, lose your mind into it. It's like it's quite bewitching, or what you call it. But so I mean to say that like it can be interesting in itself just to supervise as well. But since it's a lot of machining time, and I know that like you have a lot in with the studio and everything, like you can of course bring the laptop and be able to do studio work, or like since I will be present, it's another thing with Clemens from Maritime Robotics Lab, which I like assisted a little this morning. I was there for the first hour just to make sure that everything was prepared the correct way, and he had all the help that he requested, and then he was responsible for the supervising, but I will be responsible for the supervising for this. So you can treat your time like you intend.
Okay.
But now, since it's 1:30 midnight, what time do you suggest? Also, given the fact that this will take possibly and most certainly more than 3 hours and more than 3 hours and 20 minutes.
I can have a 10-minute breakfast and a 5-minute walk, and I'm there. So you live farther away, and you have family. So,
but then I suggest perhaps. I think that this, like, if you are okay with it, and if you don't have any like other things planned, or like you want to do in a certain order, then I think that
yeah. So because you said, okay, now we have like 3.5 hours of milling and to set it up.
Oh yeah, that is correct. So perhaps that will be like one reason to, if you're comfortable with like either having eaten or like, yeah, depending of course how you distribute your time. But would it be okay to meet at 11?
For me, it's fine. Like I have honestly nothing planned tomorrow. The only thing is that I know that tomorrow in the evening I'll probably join my neighbor to some bonfire or something like this.
Yeah.
More than this, they have nothing planned.
I suggest then that we meet at 11. And I will have like eaten a larger breakfast or like an early lunch, so that like I can endure or like but we meet at 11.
Yeah.
Preparing will take an hour usually, like with all the steps that's necessary. So then we'll be like up and running at noon, noon, and then 3.5 hours later it's 4 o'clock. And if it extends further than that, perhaps if we add 25%, then it's still like earlier than 5 o'clock, and then it's good like if the bonfire is early. Or
yeah, that's true.
It sounds good to me.
Yeah. I had one question concerning the like, I don't know how's your stand, but concerning the whole Corona situation, do you want me to take a mask with me?
Yes, I would like, but you don't have to take a mask with you because there are masks in the.
Oh yeah, I think
so I think it's good procedure, at least for me, since I'm really happy to have been given the what do you call it, vote of confidence of being a little responsible for the CNC machine. And then like if the CNC room, it's good to like maintain the rules of the workshop in the, but as I said, there are masks in the entrance to the workshop, so that's not a problem if you don't have any, or like
okay. I think I still have some, but I'm not sure.
All right. We will, because now you have exported the G-code. I would like you to upload the G-code to the KTH server. The actual the actual directory that we will run the G-code from will be a local directory on the computer at site or on site. But if you go to, I think it's ug.home, is it so? Like you, like you, like in what name begins in U? Like you, like sorry, like the letter U.
J or the
no, you, like sorry, sorry. No, but I will try to. Sorry, this was I was not. Yeah, I can do like this. U. So UG.
Oh, okay. Sorry. Okay.
Dot. No, but it's okay. But dot. Is it home? Dot. Yeah,
University of Ghana.
I think that's correct, because it's always comes up ug.home.kth.se. Okay, if you try to Google that, like if you press the down key one, and then oh, sorry, I can't remember.
What was it again? UG.
If you test to type it in ug.home.kth.se, but then to search for it, like you click there instead of, but not there, because it was right. Yeah, you picked the right one. It's the other way around. Home.ug.
So this is then this. Okay. Do you know?
It's totally fine, but be sure to bring that
on a stick,
on a USB stick.
Okay.
Because we will be moving it to a local directory, and then that local directory will get automatically synced to the machine. But it will have to be so that NC file which we exported. Yeah, perfect. And also, while we have Fusion up or still active or in the background there, we can actually input the simulated runtime. So if you select the first toolpath,
both of them.
No, you select only the first, and you see down to the right. There you see here that it says 1 hour and 35 minutes, and 1 hour 35 minutes. How long is that? 60 plus 35. It's 95 minutes. Okay, and then you can, if you Alt Tab and switch to the table. Then you can input 135 in the simulated run here, or like that. Yeah. And then in the next one, we can see what that was. 1 hour and 38. So,
but this is
I was wrong about it should be 95. Sorry,
95 and 98.
Yeah. Perfect, because then we can see, because if you go a little up and to the right, you can see here the actual time ratio. So it's like there we have like a factor of 2, but otherwise it's a factor of 1.4, a factor of 1.12. So it's a little it's a little different. We don't want it to to take twice the time that we have calculated.
No, that's not.
But like if it's if it's that, then it's like then we know for the final model, if that's the procedure that we take, that it will take double the time that we simulate, and it's good to know. But and we can also like anytime during the process we can pause, and when you pause, the spindle will retract to the clearance height, and the spindle will also like stop rotating, and then we can enter a room and see like what is the result, and like we can. I don't want to like diminish the expectations, but I just want to say that like if the first toolpath takes twice the time, and you think that like it's not viable, or you want to try the styrofoam way anyway, like it's not like you can take the decision tomorrow, like anytime, when what to do. But I look forward to see the results there, because I think that it will be really nice, but with some disadvantages of the like the ball end mill. Yeah, but we'll see. But it's really good, and you will bring the USB stick with the actual NC code file, and we'll meet like in the workshop by the CNC room tomorrow at 11.
Yeah.
Yeah, that's really good.
Perfect. Yeah.
We'll see you there, Carl.
Yeah, I'm looking forward to that.
Yeah, me too.